Learn all about React Native in this complete beginner's course from Emma Williams. She is a software engineer who specializes in React Native. Emma will teach you everything you need to know to start developing cross-platform native mobile apps using JavaScript.
App downloads continue to increase year on year, creating some big revenue. Learning how to create mobile apps is also a lot of fun. In this course, I'll be introducing you to React Native, and together we'll build a weather application. You're welcome to just watch the video or follow along. The only prerequisite for the course is that you have a text editor set up. I'll be using Atom, but you're welcome to use whichever one you prefer. Before we go any further, if you're planning to follow along with this tutorial, I'm going to start by showing you how to register for an API key, which will be needed for the application. It can take some time for the API key to activate, which is why I'm suggesting starting by registering the key now. The API key we'll use for the application is called the OpenWeather API and can be found here. So you'll need to start by registering and then creating an API key. We will be using the 5-day forecast, which is free and can be found here. We'll return back to this later in the tutorial. So what is React Native? Well, React Native is a framework which was created by Facebook and was initially released in 2015. React Native lets you create mobile apps for iOS and Android by using JavaScript. In the land of mobile apps, we have two types of apps: native and hybrid apps. When you create a mobile app, you have two choices: create a hybrid app or create a native app. When you create a native app, you write two separate applications. One will use Swift or Objective-C and is an app for the iOS platform. The other uses Kotlin or Java and is an application for the Android platform. Creating a native application gives you opportunities for fantastic user experiences, but the trade-off is that it means you need to do the work twice in order to create one application, once for iOS and once for Android. And often this means you need two development teams. The alternative is to create a hybrid app. So hybrid apps have one code base and can run on multiple platforms. And examples of these include Cordova and Ionic. So you could have one code base and the app can run on both iOS and Android. The benefit with hybrid apps is that you don't need two code bases or knowledge of multiple languages. The issue with a traditional hybrid app, though, is that you are essentially creating a web app that runs on a phone. So you have a container which renders web views. A web view essentially renders a website inside of the application. When you do this, the user experience is restricted. So this is where React Native comes in. Whilst technically React Native is a hybrid platform because you only have one code base, the app renders using real native UI components, as opposed to web views. React Native takes our JavaScript code and makes a bridge between our app and our target platform, so our components get rendered natively without using web views, and we can use platform-specific APIs and components. Consequently, we have a more performant app with a much better user experience. You're also able to extend the code and create custom native components if required. So you might have heard of Expo already, but what is Expo? Well, Expo is an external platform which makes our lives easier when we're developing, building, and deploying React Native applications. It is not compulsory to use Expo, but if you're just getting started, it is much quicker. If you don't use Expo, you have to go through the various steps of installing Android Studio and Xcode, and then making sure you have simulators and emulators running. When we use Expo, we can just run the app easily on our device by simply scanning a QR code. For this course, we'll be using Expo. So let's go ahead and get our environment set up. So firstly, we need to make sure we have a recent version of Node installed. Next, we need to go ahead and install the Expo CLI, which will help us to create our project. To do this, we just type npm install -g, because we want it installed globally, Expo CLI. Now we need to navigate to the directory where we would like to create our project. And then we can just go ahead and create it. We do this by typing npx Create Expo App, Weather App. Now all we have left to do is to run the project. So we change directories into where we want the project to run by typing cd weather app. And now we just type npm start. You can also type Expo start or yarn start here if you have yarn installed and that is your preferred package manager. Lastly, we can now preview the app on our phones. You have to make sure your phone is on the same internet connection as your computer. Then you can install the client for Expo from the App Store or the Google Play Store. You can find this by searching for Expo, and the app is free. Once this is installed, you can scan the QR code onto the camera if you're using an iOS device, or from the app if you're using an Android device. At this point, you should see the app running. For the purposes of teaching this course, I'll be running the app on a simulator, so I'll briefly go ahead in the next video and show you how to set this up. But feel free to skip this section if you're happy to run the app on your own device. So now we've looked at setting up a React Native application using Expo, I'm going to show you how to set the app up using the React Native CLI. You don't need to watch this section or do the setup if you're happy to run the app using Expo on your own device, but I'm going to show you how to complete the setup using this approach so you are aware of it. Because as I mentioned earlier, if you want to build an application using custom native code, then you need to use this approach. So we'll start by looking at iOS. For this, you need to have a Mac. If you don't have a Mac, you can still watch, or you can skip to the section where I set up an application and then move on to Android. So we'll start by following the documentation on the React Native website. We need to make sure we have Node and Watchman installed. If you want to work with multiple versions of Node, I highly suggest using NVM, and the setup for this can be found here. For those of you who aren't familiar with Watchman, Watchman detects when the source code has changed so it can rebuild the bundle automatically. Next, you need to make sure you have the correct version of Ruby installed. On your machine, you can type Ruby --version to check which version you have installed. If it doesn't match the version React Native uses, we can find more information about that here. And then you need to install this version too. You can do this by using a Ruby package manager such as RVM. So now we're ready to install Xcode, and we do this via the App Store. This will install the various tools and simulators for us to run the application. This installation can take some time, so you may want to pause the video here and let this download if you're following along. So now we need to make sure we have CocoaPods installed. If you have never used CocoaPods, it's a dependency manager, a little bit like NPM, but for iOS. So now we have everything installed, we can go ahead and create the application. It's worth noting the warning provided on the website, which says if we have previously installed the React Native CLI, we should remove it to avoid unexpected issues. So we'll do that now by typing npm uninstall -g React Native CLI and at React Native Community /CLI. So now let's navigate to where we want to create the project, and we'll do this by saying npx React Native init awesome project. For those of you who are not familiar, npx is part of the npm toolchain, which lets you run commands without installing things globally. At this point, our project should be set up so we can navigate into it by typing cd awesome project. And now we're ready to start the application. We need to use two commands for this, so it's useful to have two separate windows open in your terminal. The first command we use is npx React Native start. This command will start running Metro, which is the bundler that React Native uses. We could also run yarn start here if you would prefer to use yarn as your package manager, or even npm run start. Finally, we're ready to start the application, and we do this by typing npx React Native run iOS. Now you should see the application launch inside a simulator. As a side note, if you're more comfortable working with Xcode, you can launch the application from there. You will need to open the XC workspace, ensure you're running Metro with React Native Start, and then you can manually run a simulator. In the next section, we'll move on to launching the application via Android. In the last section, we looked at running the application using Xcode and iOS. This time, we'll look at running the application with Android Studio. The first thing you'll need to do is to make sure you have Android Studio downloaded and installed. The link to download this can be found here. Once Android Studio is installed, we need to make sure we have an emulator set up. To do this, we simply open Android Studio and select Configure. We then create our device. When you are running the application on Android, you need to make sure the emulator is launched before you do anything else. We can simply double-click the device here to launch it. If you want to launch the emulator from your command line, you type emulator-avd and then type the name. So now we can close Android Studio and type npx React Native run Android, and we should see our application launch in the emulator. If you would prefer to use your own device here, you can simply plug the device into your computer, and you should see it automatically detected. If you run into any issues, make sure you have enabled USB debugging on the device. Finally, if you run into any other issues which says could not connect to the development server, you may wish to run a command which says adb reverse tcp:8081 tcp:8081. Doing this will set the port of your Android device to the port of your computer. So now we have everything set up, let's go ahead and explore the application in its current state. I'm going to revert back to my project set up with Expo. Depending on how you set the application up, you should be presented with a basic folder structure inside of your text editor. If the project was created using the React Native CLI, you'll see a directory with iOS and another directory with Android. Inside of these directories are native entry points to the application. We also have our node modules and Babel set up. Additionally, if you set the application up with the React Native CLI, you'll also see Prettier. And we should also have a file called app.js. So to make our lives easier, we're going to add a linter for working with our project. For those of you who use the React Native CLI, you should have a linter pre-installed. But if you set the application up using Expo, you will not have this. Depending on whether you're using Yarn or npm, you'll need to run the following, which will install ESLint as a development dependency. npm install ESLint --save -dev. Now we can initialize ESLint, and we do this by typing npx ESLint -init. After this is done, we should have an ESLint rc file created with some setup, and we can modify this. We're also going to install the React Native community ESLint config. So we say npm install @React Native community /ESLint -config --save -dev. I'm going to add a couple of extra rules, but you're welcome to customize this to your own preference. So now we'll also need to install Prettier for helping us with our code formatting. To do this, we type npm install --save -dev --save exact Prettier. And now we also need to create a file for our config. So we'll type touch.prettier.js and we'll add the following. You can find out more about setting config for any of these files here and here. It's also worth adding ESLint to your text editor, depending on what text editor you have. If you're using Atom, you can navigate to Preferences, Install, Linter ESLint. Or if you're using VS Code, then you can go to Preferences, Extensions, ESLint. If you run into any issues, you may need to try restarting your text editor. Lastly, we can add a script for running ESLint inside of our package JSON. So we'll call it lint, and we'll set the value to ESLint dot. To run this now, all you need to do is type npm run lint or yarn lint. So when you're working on an application, it's really useful to know how to debug the code in order to fix any errors that you may create or run into. In React Native, we have the ability to access what is called a debug menu. With the various ways to run the application, we have slightly different ways to access the debug menu. If you're running the application on a physical device, you can shake the device to access the debug menu. If you're running the application on an iOS simulator, then you can type Command D, and on an Android emulator, Command M, if you're on a Mac, or Control M if you're on a Windows. So now we should all be able to see the debug menu, and we can see the options which are available to us. The first one is Reload. Whilst these days React Native has hot reloading available, it's still useful to know this option is here. You're also able to type Command R, so you can do this without launching the debug menu. The next option is Debug. Selecting this will open the React Native debugger, and once this is open, you can access the JavaScript console, just like when you're working with a website. So you can do this in Chrome by selecting View, Developer, JavaScript console, or you can type Command, Option, and J. This means we can use console logs inside of our application and inspect them. So let's navigate to our application.js file, and we'll add a console log. Now let's go back to Chrome, and we can see our console log is printed out to us. So when you're working with mobile apps, each platform has a set of native components. Whilst the names of these differ depending on the platform, the outcome is the same. They help you lay out the UI of the application. So for example, on iOS, if you're working with images, you could use a UI image view, whereas on Android, you would use an image view. On iOS, this may be contained within a UI view, whereas on Android, this may be contained within a view group. With React Native, we use JavaScript in our components, and when the app runs, React Native will then create the correct UI for the different iOS and Android platforms. So in order for us to create our UI, React Native has some core components which we can use. If you're familiar with React, you can think of this a bit like how you use divs and spans or p tags for your layout. Here are some of the core components that React Native provides. So we may wrap our layout inside of a view, and then inside of this, we may want to display some text using the text core component, or a button using the button component. So in our app.js file, let's go ahead and use the core text component to add some text, which we will wrap inside a view. You can think of a view a bit like a div, so unless we apply styling to it, the view won't be visible. So we'll create a view and give it a height and a width of 100. And a background colour of orange. Inside of the view, we'll use the text core component and print out some text that says Hello World. Now let's run this on our device. We can see the view with the orange background, which also contains our text. So you may be wondering what the syntax is with all these tags. It looks a bit like JavaScript and HTML, and it's called JSX. JSX is an extension of JavaScript, and it stands for JavaScript and XML. So we use JSX when we're creating elements, And because it is JavaScript, we're also able to use JavaScript with it. So we could change our text to use a variable instead. Let's give this a go. So before the return statement, we'll create a variable called message. And we'll assign to this our string, which says hello. Now, because we're going to be evaluating a JavaScript expression when the element is rendered, we need to use a set of curly braces. Inside of these curly braces, we place our variable, so we use the message variable here. Now let's return to our simulator. Nothing has changed visually, but we just used a variable to render the text. So before we start building our application, there's a few other things we need to be aware of when we're working with components. You need to import React, and then you need to import any of the core components that you wish to use. Your component is a constant function, so it starts with const, and any JSX must be returned. Lastly, you need to export the function components, and we do this using export default. So we've come across the term component a few times in this section. We have the core components, which we import, such as view and text, but we also refer to everything in the file as a component. We use the term element to describe what we see on the screen, but this is contained within what we call a component. One of the best things about React and React Native is how it makes you, the developer, break down what you are building. The UI is separated into different pieces. If we take a look at the Open Weather Map website, we can see we have a navigation bar with various links. We have a search text input, we have a map, and some diagrams, and also some city details. All of these pieces can be broken down into separate components before they are rendered on the screen. This makes working with code a lot of fun, but it also makes it very extensible and clear. So now we have a basic understanding of how React Native works. Let's go ahead and create our first component. So now we have a basic understanding of how React Native works. Let's go ahead and create our first component. So in the app.js file, let's delete everything. The first thing you need to do when you create a component is to import React. So let's go ahead and do that now. We say import React from React. Next, we'll import the core components that we are going to use. In our case, we'll just use view and text. So we say import, and then we use a set of curly braces. Inside the curly braces, we say view and text. Outside of the curly braces, we say from React Native. There are a few different ways to create components, but we're going to use the constant function approach described in the last section, and we can look at these other approaches a bit more later. We're going to call this component app. So we say const app, followed by an equals sign, a set of parentheses, an arrow, and a set of curly braces. Lastly, we need to export the component, so we say export default app. Our component does not render anything, but this is the basic setup for the component achieved. Now we can add the JSX to return some UI. We start by using the return keyword, followed by a set of parentheses. We'll start by adding the view, and then we'll also add the text. For our text, we say current weather. So let's take a look at the simulator. It's very hard to see the text. The layout of the text will vary slightly depending on which simulator or emulator you're using. This is a bit like a layout on a website varying depending on the size of the computer screen or the different browser. For this reason, just adding padding or margins to fix the layout is not a great approach, because you might fix the layout on one screen, but it won't be guaranteed to look better on a different screen size or device. And you also want to be mindful that people might be using your application on an iPad or tablet too. So with this in mind, React Native provides another core component which can help solve this problem. It's called a safe area view. Let's update our code to use this. So we start by adding it to the import. And then we'll wrap the whole element inside of a safe area view. Now, if we check the simulator again, we can see the content has been rendered just below the status bar of the device. So now we made our first component, let's move on to discussing styling. In React Native, we don't have access to standard CSS. Instead, we use a JavaScript object. The naming of the properties is usually the same as with standard CSS, except that we use camel casing instead. So font size becomes font size, for example. There are a few different ways to apply the styles, but we're going to start by using inline styles. When we use inline styles, the styles are applied as we create the component. So we're going to start by applying a background colour of pink to our view. We'll talk about props shortly, but for now, just think of them like properties, like when you add key value pairs to an object. So we set a style prop on our view. We say style equals, and then a set of curly braces. Inside the curly braces, because we are using inline styles, we add a second set of curly braces. And then we say background colour, a colon, and then a string with the value pink. Let's save this and view it in the simulator. We can see our screen with our pink background colour applied. So whilst this works, as our code becomes more complicated, applying inline styles in this way can get quite messy. So as it's always good to focus on writing quality code, we're going to use another approach, and this is called stylesheet.create. So we can define our styles all in one place. To do this, we need to import stylesheet from the React Native API. The list of the APIs we can use with React Native can be found here. So we go ahead and we create a style object. Usually, it's best to do this before you export the component. So we say const styles equals stylesheet dot create. We follow this by a set of parentheses and then a set of curly braces, because we're passing it an object. We can then go ahead and add our styles. So we're going to call this attribute the container. And now we can add background colour. Now we need to add this to our component. We can remove the second set of curly braces and then say styles dot container. Let's save this and view the simulator. Nothing has changed visually, but we have moved away from inline styles and started using stylesheet.create instead. When you're applying styles to your component, it can be useful to refer to the documentation, as these props vary slightly depending on what core component you are applying the styles to. You can find out more about these here. So we've just applied the background colour, but we only have the background colour around the text, not the whole screen. So let's add a few other things here. We'll add a style to the safe area view called Wrapper and apply Flex 1. We'll also add Flex 1 to the container. Flex is part of the layout props. When we're building React Native applications, positioning and layout is done using Flexbox. And the reason for this is that it lets us build our layouts for the various different screen sizes that we will encounter. So unlike with the web, you don't have to say display flex. For those of you who aren't familiar, Flex will define how much of the screen the view should fill, and you provide a value from 0 upwards. So we're saying flex of 1. And this is the equivalent of saying the view should fill the entire screen, because we're only using one view group. When you want to start to split the view into different areas, you may need to start to consider the different values depending on how much space you want each part of the screen to fill. So if you're using Flex 1, then all the components up the tree must also use Flex 1, which is why we also apply it to the outer safe area view. Let's also make our title display in the center of the screen. We can do this by saying Align Items, Center. So this centers the text horizontally. If we wanted to display the text in the center, vertically, we would just use Justify Content. We want our text to just be centered horizontally. So the goal for this screen is to show the user the current weather. We want to display the actual temperature, what the temperature feels like, the high and low values, and then we want to display a description and some additional text about the weather. Lastly, we also want to display an icon and a background colour. Eventually, we want this screen to be dynamic, so the icon, background colour and message that we provide change depending on the weather. For now though, let's just hard code everything in so that we can get our basic layout, and once we have looked at getting the data from the API, we can update this so it works dynamically. So let's start by adding our text for the first value that we want to add, which will be the temperature. And for now, we'll just add 6 for the value. We'll add another text for the fields. So we'll say feels like 5. Let's add the high and low in another text. So we say high, colon, 8, and low, colon, 6. So let's start by adding the layout styles for these. We'll start with the temperature and we'll call this temp. We'll give this a colour of black and a font size of 48. You don't use units, just the numbers for the styles in React Native. All dimensions in React Native are unitless and represent density-independent pixels. So this is an absolute unit of measurement for the device. For the feels like text, we'll add some styles called feels. And this will have a font size of 30 and a colour of black. We also don't now need our title, so let's delete that. Let's also add some styles for the high and low text. We'll apply this to both pieces of the text and we'll call it styles dot high low. We will give this a colour of black and a font size of 20. Let's view the simulator and see what we've done so far. We want the text for the high value and the text for the low value to appear on the same line. To do this, we can set the flex direction to use row. We'll start by making a container for these pieces of text, and then set the flex direction on the container so that it applies to the children, which is the high and low text. So we start by wrapping both pieces of text in a view. And we'll call the styles for this high-low wrapper. We'll then say flex direction row. Now, if we check on the device again, we can see the high and low text both appear on the same line. On the bottom of the screen, we want to add some more details about the current weather conditions. So we'll create another view, and inside this we'll place two pieces of text. Inside the first text, we'll say, "It's sunny." And inside the second, we'll say, "It's perfect t-shirt weather." We want this text to show at the bottom of the screen, so let's apply some styles. We'll call the attribute body wrapper. And set justify content to flex end. This is so that it displays on the bottom of the screen. Let's also add align items with flex start so that the text displays on the far left of the screen. We're also going to change our container so that it only wraps the items we want to display on the top portion of the screen. So we'll move the closing brace for this view to be just before the view with the body wrapper attributes. Now let's also apply some styles to the text with the weather description. We'll call the first one description, and we'll call the second one message. Inside description, let's add a font size of 48. And let's make the message a bit smaller, so this one will have a font size of 30. Now let's check the simulator. We have our basic layout set up, but it doesn't really look very pretty, nor is it very dynamic. We also see that our background colour does not apply to the whole screen. This is because we changed the container to only wrap the items at the top of the screen. We can fix this by moving the background colour into the safe area view wrapper. Let's do this now. Let's check the simulator again. And we can see everything now looks as we expect. In the next section, we'll look at adding an image to the screen. So we want to display an icon that represents the weather to the user. There are a few ways we could do this, but I'm going to use a library which is installed by default when we use Create Expo App. If you did not create the app using Expo, you can manually install it now. It's called React Native Vector Icons, and it provides us with a variety of icons that we can use within our project. The library Expo installs is built on top of the React Native Vector Icons one. To explore the Expo items, you can see them here. For now, we just want to use an icon that represents sunshine. So let's search for this. When we click on the icon, it provides us with the details we need to use the icon. So to start, we need to import the icon family. Next, we need to add the icon to our component. We're going to show the icon at the top of the screen. Let's also change the size to be 100, so it's a bit bigger. Let's have a quick look on the simulator and see how this looks now. So we can see the icon has been successfully added to our screen. The top half of the screen is starting to look quite busy, so let's center all of this content by adding Justify Content Center to the container. Let's also add some left padding to the text at the bottom of the screen. So we'll add padding left with the value of 25 and a margin bottom of 40. So in React Native, when we're adding things like margins and padding, we can either provide a single value to the padding or margin, which will affect the top, right, bottom and left. Alternatively, we can apply separate values to the different areas, like we're doing. Now we have our first component, so we can look at moving on to using it with real data. We're going to start by moving our current weather component into another component. There are a few different approaches you can use in terms of structuring your app, and these often vary depending on the complexity of the application. We're going to start by creating a directory called src. Inside of this, we're going to create another directory called components. Inside of the components directory, let's create a file called currentweather.js. So let's paste everything from the app file into the current weather component. Let's also rename the component from app to current weather. We also need to make sure it's exported. Now inside of the app file, let's delete everything. Let's redefine our component again. So we say const app equals, and then we use an arrow function with parentheses. At the bottom of the file, we say export default app. Inside the body, let's add return with some parentheses. We'll also import React, and let's also import Vue from React Native. Lastly, we'll also import style sheet. Let's set up the styles. So we say const styles equals style sheet dot create, and we'll set an attribute called container. We'll give this a flex of 1. Let's now add the view to our component, and we can apply the styles. We also want to use our current weather component, So we'll import this to start with. We say import and say current weather. And then we need to provide the path that we want to get the file from. Now all we have left to do is to render this inside of the component. Let's save this and check everything worked in the simulator. Everything looks good. So before we go any further, let's take a step back and review what we have just learnt. So far, we have learnt how to set up an app with Expo. We have looked at how to create and import a component. And we've also looked at basic styling for our components. A component is a function that returns some amount of JSX. The JSX is the syntax we use to make our lives easier for readability purposes. But under the hood, JSX gets turned into JavaScript by using Babel. And you can see more about the conversion here. Inside of our components, we show or render something to show the user. We can then export the component and use it elsewhere in our application. When it comes to importing a component into another component, we use the keyword import and a relative path, so we don't have to append the .js. When we work with React Native, we are working with a framework that promotes lots of component reuse, because it's a component-based framework. So in our application, we'll usually have a root component, which in our case is the app.js file, and this acts as the entry point for the application. But then we'll usually have multiple other components, which are usually stored inside of a directory called components. Inside these components, we may then import additional components. So for example, we may create a custom button and reuse it throughout our application, as opposed to redefining it in multiple places. As a side note, you're able to have more than one component in a file, but just having the one makes the code much easier to work with, and this is very important, especially when there's more than one developer working on a project. So this component-based architecture not only helps with debugging and easier testing, but there's also a convention in coding called DRY, which stands for Don't Repeat Yourself. It's good to have this at the back of your mind when you're working with a component-based framework. So our app is going to have two additional screens, one which will show the upcoming weather, and one which will show some details about the local city to the user. As we're still getting familiar with React Native, we're going to move on to implementing the initial layout for these screens first. After we've done this, we'll have a look at how to make them dynamic by fetching data from the OpenWeather API. And then we'll look at how we can wire up all these screens together with navigation. So we're going to start by creating the component to show the upcoming weather. We'll call this component upcoming weather, so we can create a file inside of our components directory. Let's also create the boilerplate for our component. So we say const upcoming weather equals, and then we use a set of parentheses, an arrow function, and a set of curly braces. We'll also make sure to export the component, so we say export default upcoming weather. We need to import React from React. And then we'll import safe area view from React Native. Inside of the component, we'll say return, and we'll add a set of parentheses. Inside of the parentheses, we'll add the tags for the safe area view. Let's also set up our styles. So we add style sheet to the React Native import. Then before our component is exported, we say const styles equals style sheet dot create. we add some parentheses and curly braces. We'll also create a container and we'll add this to the safe area view. We'll give this flex of 1. Let's also add some text. So we need to import this. And now we can create the text. We'll give this the message, upcoming weather. In order to check we've set up the component correctly, we can view it in the simulator. Before we do this though, we'll need to add the component to our app.js file. So at the top of the file, just like we did with current weather, let's import the file now. Then in the render, let's remove current weather and add the upcoming weather. Let's check the simulator. We can see our component has been set up correctly, and we get to see the upcoming weather text we added. So what are our goals for this component? Well, we want to be able to show the user a list, and in the list, we want to show the user the date and time, an icon, and what the weather will be at that time. Before we do this, we need to have a look at how lists work in React Native, as showing lists to a user is a core part of working with mobile apps, and it's something you're likely to come across very often. So rendering lists inside of mobile apps is a common task you may find yourself presented with. Take a look at your favourite social media app, or have a look at a news app. Because of the often limited screen size we have on a mobile device, very often the information is displayed to us in the form of a list, and we have to think carefully about how we go about using it in order to make the best of the screen space we have available to us. So in React Native, when we work with lists, we have a choice of a few core components that we can use. Primarily, these are called flat list and section list. Additionally, we have virtualized list, but it's better to try and use the flat list or section list components because virtualized list is essentially a diluted version of these. And unless you need a heavy amount of flexibility, you should be able to fulfill your needs with the flat list or section list components. So what's the difference between flat list and section list? There are a few differences in the way you implement the two, which we'll look at shortly. But in terms of the end result, if you simply have a list that you want to display to the user, then you can use flat list. We can take a look at the example on the React Native website. So we see 3 items in the list here. If I try to scroll, well, not a lot happens. However, if I add a few more items to the list, we can see what happens when the list is bigger. I'll add 3 more items. And just amend the title and ID properties slightly. So now we see our longer list, and we can scroll through the list here like so. Let's also have a quick look at section list. So here we can see the list, but we can also see how it's broken up into sections, and each section has its own items. So we have main dishes, sides, drinks, and so on. So the outcome here is that if you have a collection of data that you need to display to the user, which needs to be broken into sections, then you should use section list. Otherwise, flat list will suffice. So let's move on to looking at how these lists are implemented. On the right-hand side here, I can see all the properties that are available to us to use. However, there are 2 of these props with a red dot next to them. If we scroll down the documentation a bit, we can see that these are marked as required. So all the other props are optional, but render item and sections are compulsory. Equally, if we go ahead and look back at flat list, we can see there are again a lot of props available to us, but this time we have two marked with a red dot: render item and data. So the takeaway here is that both lists are heavily customizable, but both have two things that you need to provide in order to implement them. We are going to be using flat list in our app, so let's start with looking more deeply at this one. The first one of the required props is data, and for this we need to pass an array. Inside of the array, we have the data that we want to be displayed on the screen. So if your list was showing a list of cars, then you may have an array containing names of cars. If your list was displaying a list of students' test results, then perhaps you would have an array containing the students' names and their test scores. With flat list, you're able to simply pass in an array. Let me update the code here to show this. I'm going to remove all the objects. And then I'll simply pass in the titles to the array. So I'll also remove the title keys. In the item function, I'll also remove the reference to title and simply refer to the item itself. So now when the list renders, I can see the three items from the data array. It's worth pointing out here that this is one of the differences between flat list and section list. In that with section list, you must pass in an array of objects because of the fact the list is broken up into sections. In reality, when you're working with flat list, because quite often you're rendering dynamic data, such as that from an API, you're probably more likely to end up also passing in an array containing objects too. So now we understand the required data property. Let's have a look at the second required property, which was called render item. The render item prop gets passed a function, and this will get called on every array element. Its job is to decide how that element then gets displayed to the user. So you can think of it a bit like the list's own render function. If the function for rendering the item is very simple, we can place it directly in the definition for the flat list. Quite often though, we end up passing it a reference to a function, as we may want to render out quite a few things for our list element. We pass a single argument to the function, which is an object, and this is the item you are rendering. So if I refresh the screen and go back to the original example here, we can see it renders the title from each item in the data array. So if I added another property to the items in the data array, let's say amount, and then I pass that into the render item, and render an additional piece of text to render the amount, we then get to see that each item in the list renders this value too. If you're working with section list, then render item works in a similar way. So before we move on and look at implementing a list in our app, let's recap everything we've just looked at with lists. We've learned that in React Native, we have two main core components that we can use when we're working with lists: flat list and section list. We know that flat list is more of a standard list, but we can use section list if our data needs to be displayed in sections. We then looked at what we need to do to get our lists up and running. We've seen that we must pass in some data, which must be an array. And if we're using section list, then this must also be an array containing objects. We've also seen that we must additionally use a prop called render item, and we use this to display the list element to the user. So let's now move back to our code and figure out how we're going to use a list. So, back in our upcoming weather component, let's start by importing the flat list core component. So inside the React Native imports, we just say flat list. Now, under our upcoming weather text, let's use this. So we start by typing flat list. We know we need the required data and render item props, so let's add these too. Obviously at the moment, we have not yet set up our app to fetch any data, so for now, let's write this out by hand. We'll start by declaring the variable for data outside of our component, and we say const data, and we'll assign to this the required array. Inside the array, I'm going to just place 3 objects, as for now, this will be enough before we wire up our app to use the real data later. If we have a look at the OpenWeather API documentation, we can see some examples of the data sent back to us. There is obviously a lot we can work with here, but for our list, we're just going to be showing the weather at 3-hour intervals, and we only need a few bits of data from the response. We'll want to use DT text for the current time, the min and max temperature, and a description of the weather. So I'm just going to paste in some example code here, and you can pause the video now if you're following along. So now we have our data, we can pass this into the flat list. So we should have our data prop defined. We use an equal sign and a curly brace, and then pass in the data. The next required prop we need to add is render item. We're going to create a function to pass into this, which will render what we want to show to the user. In our case, we're going to create a separate component for the item. So we want render item to render the component that we'll be creating. Let's start by creating the component for the item. I mentioned earlier that it's best to keep components in their own files, but whilst we're setting up our list, I'm going to create it in this file, and then when we do some refactoring, we can move it later. So we're going to call this component item. So we define it just like we have with all our other components. We say const, then the component name, which is item, an equal sign, an arrow, and some curly braces. We then say return with some parentheses. We're going to be rendering the DT text, min, and max weather, and then the weather condition. Let's add these props now. I'm going to define props in the parameter, and then using destructuring, I'll pull these out. So I'll say const, a set of curly braces, an equal sign, and props. This is a convenient and clean way to access props inside of your components. Inside the curly braces, I'll add DT text, min, max, and condition. Now inside the return, let's start by adding a wrapper or container. So I'll add a view here. Inside the view, I'll add 3 pieces of text. In the first piece of text, we'll add the DT text prop. So I need to use curly braces because we're using a prop. In the second, I'll add min. And in the third, I'll add max. I'm also going to add an icon, which will go above all the pieces of text. I'm going to do this using Expo icons again, so we need to import this. Under our React Native imports, let's say import. Then we have our curly braces. And inside this we say feather. Then we say from @Expo /vector icons. We're going to be dynamically using different icons based on the weather condition, but for now, let's just add one for the name sun, as we're going to need to create a file which handles some of the configuration for us later in order to correctly map the feather icon names with the Open Weather Map weather descriptions. So I add feather at the top of the view. I then set a name prop, which is equal to sun. We set the size to be 50, because we're using a list and we don't want the icon to be too huge. And then we set the colour to white. So now we have our list item component. Let's create the render item function inside of the upcoming weather component. So before the return keyword, we say const render item, and then we set this up like an arrow function. So we use an equal sign, parentheses, an arrow, and because we want to render something, we'll use another set of parentheses. For the parameter, we want to pass in the item, so we use a set of curly braces and pass in the item. We need to pass the required props to the item component, so we say condition, and set this equal to be item dot weather. We use square brackets to get the element at the position of 0, then dot main. We set the DT text, and this is equal to item dot DT text. We then set the min, which is equal to item dot main dot temp min, and then max, which is equal to item dot main dot temp max. Now in our flat list, all we need to do is pass in this function. So we say render item and pass in render item. Let's save this and run the app in the simulator to see where everything is at. So, in the simulator, we see the upcoming weather text, but then we see the 3 items from the data that we passed into the flat list rendered on the screen. Obviously, it doesn't look very pleasing, but we can address that in a moment. Before we do that though, there's one other thing we need to add to our flat list. If we take a look back at the docs on the website, we can see the example also includes something called a key extractor. What is this? Well, let's read through the description. It says, it is used to extract a unique key for a given item at a specified index. Key is used for caching and as the React key to track the item reordering. The default extractor checks item.key, then item.id, and then falls back to using the index like React does. So to summarise, when you're working with lists, you need to provide a unique key to each element in the data. The reason behind this is largely performance-based, and it means that under the hood, React Native is able to keep track of each item in the list. Imagine you're working with a really long list, say one with over 100 pieces of data. When something in the list changes, for example, if an element was deleted, then because of the way React Native works, when the re-rendering happens, everything would get rebuilt from scratch. By providing the key, it means that if an item changes, this is not necessary, and instead, the list can be recalculated. and as such, the list can be updated rather than rebuilt. The requirements for the key are that it must be a string, and each element must have its own unique ID. We can either add a key to each element in our data, or we can use key extractor to add the key for us. In our data, we could go ahead and add keys to each item. But because each item has its own DT text key and value, which, because it's based on a timestamp, is unique for each item, we're going to use that for the key. So let's start by adding the key extractor to the flat list. So all we have to do inside curly braces now is say item, arrow, and item.dt text. As a side note, if you ever see this warning, then it's essentially telling you that this is what you need to do to fix it. Before we move on to making our list look a bit better, let's just have a quick look at some of the other props which are available to us to use on the list if we wanted. So we have item separator component, which is something that gets rendered between each item in the list. This would be good for visual purposes if you wanted to add something that distinctly separates each item in the list. Let's try it out. So I type item, separator, component. An equal sign, and then I'm going to add an inline function. I'll add a view. And now I'll add some styles here. So I say background color, red, and height, 2. So now in the list, I can see this is rendered between each item. Let's refresh the screen. List empty component is another useful prop to know about. It means that if the list is empty, it will automatically display some other content to the user, which is a great consideration if you are depending on data fetching. So I start by creating a component called empty. I'll give this a view. And I'll add some text. And for the text, I'll just say empty. Now in the list, I define the list empty component prop. And I pass in my empty component. So now if I update the data array so it's empty, we get to see this in action. And I see the empty component instead displayed on the screen. There's also a list header and list footer, which means we could display either a header or footer in our list. There's obviously a lot you can do with your lists, and it's good to spend some time getting familiar with the documentation here and playing about with everything. The main things you must remember though are that you need to provide the render item and data to the flat list, and you need to provide a key of some sort to the data. You don't need to worry too deeply about performance, especially if you aren't working with a very large list, because flat list only gets re-rendered if the data changes, and only renders the items currently displaying on the screen, not everything at once. But as you start to build bigger and bigger lists, it's important to have performance at the back of your mind when you're building out the list. So let's go back to our code and see what we can do to make everything a bit more visually pleasing. The first thing you may have noticed when we checked the simulator was that you could not see the icon. The reason for this is that the icon colour is white, and we have not added any background colour to our screen, so this is currently defaulting as white too. So let's start by updating the style attributes in our container. I'm going to start by importing status bar to our React Native imports. And inside the style sheet, I'll add margin top. And I'll set this equal to status bar dot current height or 0. This is basically a constant from the status bar component, which means we're taking into account both platforms and saying to initialize with the current height of the status bar for Android or use 0. Next, I'm going to set a background color to red. Now I'm going to set the view of the item to be style equals styles dot item. I'll add this to the style sheet. I'm going to set padding to be 20, margin vertical to be 8, margin horizontal to be 16. I'm going to set a flex direction of row and justify content to be space around. This is so the items in the row are evenly distributed. I'll set align items to be center, border width to be 5, and also a background color to be pink. Next, I'm going to set style equals styles dot temp on both the min and max temperatures. I'll add this to the style sheet. I'll give this a colour of white and a font size of 20. Lastly, I'll set style equals styles dot date onto the DT text, and in the style sheet we'll add this. We'll set colour to be white and font size to be 15. Let's save this and view it in the simulator. We can now see everything, and the list items are much more distinct. We obviously have some way to go with this still, but it's a good start. The next two things that we're going to do are add an image to this component, which will let us discuss how to use images in React Native, and then we'll extract out the item component into its own component, which will let us do a bit of refactoring and also talk a bit more deeply about props in React Native. But let's start by looking at how we go about using images in React Native. So, in React Native, we have a few different options available for when it comes to working with images, for example, local or network images. On the example on the React Native website, we can see both of these approaches in action. So, we can see the image core component imported and then used. We can see that a source prop is set in the first image. So this differs slightly from the web, where you may use src, and now we have the full word source. A require statement is then placed, followed by the path to the image. The other way to load the image is by using a network image, and this means we load the image from a URL instead. This is more standard practice when you're working with API requests. So we can see here we use the source prop again, but this time we pass in an object with a URI key, and the URL is set as the value. There are a few other caveats worth pointing out when you're working with images. If you're using a network image, you need to explicitly state a height for the image. You should also be aware of the supported types of images in React Native. Additionally, when you're sizing the images, in general, you can give the image a fixed height and width, or you can use aspect ratio with height and/or the width to size the image. Lastly, it's worth being mindful of image storage sizes when you're using static images, so not the network images, as these will get bundled when you ship your application, and if you have a lot of images, they can start to eat up memory. If you've seen file names with 2x and 3x for images, it's because it's standard practice to provide the same image in 3 sizes in order to account for the different screen resolutions. So we're going to get an image to use for our app from a website which provides royalty-free stock images. It's called Pixabay. If you navigate to the Pixabay website and then search for clouds, whilst you're welcome to use any of these images, I'm going to use this one here. So I'll select the image, and then I'll select to download the image. Back in our app, I store the image in the assets directory, which is where we store static content. So we could actually add another folder here for the images, but I'm just going to add it straight into the directory. So now we are ready to use the image in our upcoming weather component. We need to start by importing the core image component inside of our React Native imports. Now, inside the render, under the text, I'm going to add the image. So I add image and the self-closing tags. I then type source, an equal sign, and some curly braces. Inside the curly braces, I say require and a set of parentheses. And then I type the path to the image. I'm also going to set some styles, so I say style equals styles dot image. I then set this inside of the style sheet, so I say image here too. I'll give this a height of 100 and a width of also 100. Let's save this and view it in the simulator. So we can see our image has rendered successfully. The problem with this approach for us is that we're going to want to display the image as the background to the screen, and we can't give children to the image component. In cases like this, there is another core component that we can use instead, and this is called ImageBackground. ImageBackground works much like image, but as the documentation here says, you can add whatever children to it that you would like to layer on top of it. That's the perfect behaviour that we're looking for. So let's go back to our code and we'll add in ImageBackground. So back in our upcoming weather component, let's change the import from image to be ImageBackground. Now, inside the safe area view, just before the text, let's move our image here, and we'll change it to be ImageBackground. Because this is now going to accept children, we want to change it not to use self-closing tags. So we'll add a closing tag before the closing tag of the safe area view. We're also going to change the styles to use flex of 1. Lastly, let's also change the background colour in the safe area view to be something that blends in better with our image. So we'll use royal blue here. As a side note, you can see all the colours available to use with React Native here. So we can see now we have our image background applied and our safe area view blends in with the image much better. So earlier in the course I mentioned we would take some time to understand what props are in React Native. If you've worked with React before, then they're the same in React Native. For those of you who are new to React and React Native, it's important to understand props, as they are a key feature of React Native. So what are props? The term prop is just short for property. So when you create an object in JavaScript, you add properties to the object, and you give the properties a value. So for example, if you created a dog object, as dogs have legs, then legs could be added to the dog object as a property, and then given a value, which most of the time would probably be 4. In React Native, we can think of props in a similar fashion. They are just properties which are given a value of some sort, but they're used as a way to pass our data down from the parent to a child. So to visualize this a bit more clearly, imagine we had a house component, and this would be the parent. We want the house component to render a room component. This will be our child, and we want this to render 4 times, because our house is going to have 4 rooms. When the room component gets rendered, we want to be able to pass down the name of the person whose room it is. So to implement this, we would have the house component, and every time we render the room, we would set a room owner as a prop. Inside of the room component, we would be able to access the room owner prop and use this in some way. So for example, we could set a piece of text which would display the value of the room owner. So instead of creating 4 separate room components, we just have the one, and each time it's customized to our requirements. So now hopefully we better understand that we can use props to customize our components. When we added the image background core component to our upcoming weather component, we used a prop called source in order to set the image, which would be displayed to the user. Core components inside React Native usually come with props which can be used. If I take a look at the text core component, I can see the list of props available to us. So for example, I could set the ellipsize mode or disabled. The same was true when we worked with flat list, and we had to set the data and render item props. Just like with the core components in React Native, we can use props in our own components, and by doing so, we can customize a component. But it also means that we're able to make the component more reusable, and component reusability is a key concept when you're working with React or React Native. So back in our app, let's look at a little demo of this in action. We won't use this in our final code, but I'm going to create a file called ourchild.js. We'll set this up like a basic component. So I start by importing React from React. I'll then import view and text from React Native. Once the component is set up and exported, I'll say return, and then I'm going to use a set of parentheses. I'll then render a view and also some text. I'm going to use inline styles here as this is just a demo. So I'll give this a height of 200 and a width of also 200. And I'll also set a background colour of red. Inside the text, I'm going to want to set some text to display. So this is where we're going to display a prop. The prop will be sent down from the parent, which in our case for this example will be the app.js file. The name of the prop will be message. So to display the value of the prop, we need to use curly braces. So I type the curly braces and then the prop name, which is message. We also need to set the prop as an argument into the component itself, and we do this inside of curly braces here. Alternatively, we can just say props here and then destructure the value. So now let's go back to our app.js file. And here we can render the rchild component. For this example, I'm going to remove the upcoming weather component temporarily. So we need to start by importing the rchild component. And then we're going to want to use this 3 times. Each time we want to use a different value for the message prop. So we start by adding the prop, and then we use an equal sign and some curly braces. Inside the curly braces, we can set the value. The first one will say hello. The second one will say greetings. And the third one will say goodbye. Let's save this and view it in the simulator. When the app runs, we can see our child component is rendered 3 times. And each time, through the use of props, the message is displayed with its different values. Before we review what we've just learned, let's revert the app.js file back to what we need for our app. So we'll delete the references to the rchild component. We will also put back the upcoming weather component. Lastly, let's go ahead and delete the rchild component. Just before I do this, I want to point out one other thing with regards to file and folder structure. We'll come back to this later, but it's better practice once you start using components to have a directory structure where you have a folder for your screens in the app, and then a component folder where you store your components. So the screens are like the screens the user will visually see. So for example, upcoming weather would be a screen. But then we have a component folder where you store your components, which are reusable components, and the code for things like UI, such as buttons, and perhaps alerts or footers. So now let's delete the rchild component. Before we move on, let's just recap what we've just looked at. We have just looked at what props are and how they let you pass in data from a parent to a child in order to promote component reuse in React Native. We've also looked at props with core React Native components and also with custom components. There are a few more points to consider when you're working with props, and these are really, really important to have at the back of your mind. Firstly, props are immutable. This means that they can't be changed once the component is created. We pass the props from the parent to the child, as we've just discussed. We use unidirectional data flow when we're working with React and React Native. Essentially, this means that data is only able to move in one direction, from the parent to the child. The outcome of this is that our lives are much easier. Imagine if you're driving on a road and cars could drive in both directions. You'd have a collision pretty quickly. This would be the same scenario with our data, so unidirectional data flow keeps things straightforward. So, now we are all much more familiar with how props work, and we should hopefully now be becoming more familiar with React Native itself. Let's take a bit of a pause and do some refactoring to the current state of our application. In the last section, I mentioned that one approach to structuring code is to split the code into components and screens. And then I discussed the benefits around doing this as you start to use more components within your screens. In this section, we're going to do this. Then, we're going to move the item component for the upcoming weather flat list into its own file inside the components directory. We'll also do some other general refactoring, so our code is a bit easier to work with moving forwards. So to start, in our src directory, let's create another directory called Screens. Now let's move the current weather and the upcoming weather components into this directory. These components are core screens for our application, so it makes sense that this is where they are stored. Now, we need to go through these files and check there are no imports we need to update. And then we also need to check the same thing in the other place these files are used, which is in the app.js file. It's important to follow this process every time you extract some code. Otherwise, when you run the app, you'll run into errors. So let's try running the app in the simulator now to check that nothing has broken. Great. Everything looks okay. The next thing we're going to want to do is to create a file for the item component, which is rendered by our flat list inside the upcoming weather screen. So inside of the components directory, I'm going to create a file, and for the sake of being a bit more descriptive, I'm going to call this list item. Next, I'll copy and paste the code from the upcoming weather component into the list item component. I'll also need to update the imports. So I say import React from React. And then I'll also import view and text from React Native. Additionally, I need to import feather inside curly braces from @expo/vector icons. Then we also need to make sure the component is exported so it can be used within the upcoming weather screen. So I say export default list item. The next thing we need to do is import style sheet into our React Native imports. And then we need to set up the styles. So before the component is exported, I say const styles equals style sheet dot create. Then I need to use a set of parentheses and a set of curly braces. So we're going to need to bring the styles over from the upcoming weather component, but obviously we only need to use the relevant styles here. So I'll need the item, date, and temp styles. I'll grab these now. And then I can also delete these in the upcoming weather component. Additionally, I can now delete item in the upcoming weather component. And then I need to change the render item to return the list item component as opposed to item. We're already setting the props for the component here, but let's check this is all properly set up in our list item component too. Everything looks good. I see props set as the parameter, and we already have the destructuring for the props in place. So now the last thing I need to do is import list item into the upcoming weather component. So I say import list item from, and then I add the path, which is components / list item. I'll also remove the view from the React Native imports here, as this is no longer needed. For the sake of making our code as clean as possible, we can also destructure our styles. So before the return, I say const, then I use a set of curly braces, and then I say equals styles. Inside the curly braces, I'll place container and image. Inside the render, I can then remove the styles and the dot for these attributes. I'll do the same in the list item component. So before the return, I say const, I use a set of curly braces, and say equals styles. Inside the curly braces, I place item, date, and temp. Inside the return, I can then remove the styles and the dot for these attributes. Let's save this and check everything has worked in the simulator. So visually, nothing has changed, but we're now using the list item component from inside of its own file when we use render item inside the flat list. Before we move on to looking at how to wire up our screens with navigation, there is one other screen we're going to implement. This screen will show some details about the current weather location. So let's set up the boilerplate for this screen now, and then we'll look at what will be shown on the screen. This component will be called city. So inside of our screens directory, we can create a new file and call it city.js. Inside the file, we do our standard setup. So we import React from React. And then we'll import safe area view, text, and style sheet from React Native. Then we'll set up our component. So I say const city equals, then I use a set of parentheses, an arrow, and some curly braces. Next, I'll export the component. So at the bottom of the file, I say export, default, city. Inside of the curly braces, I say return, and then use some parentheses. For now, I'll just add the safe area view. And inside this, some text. For the text, for now, we'll just say city. Let's add some basic styles here to get this set up. So before the component is exported, I'll say const styles equals style sheet dot create. I'll then add a set of parentheses and some curly braces. Next, I'm going to add an attribute called container. And I'll give this flex of 1. Lastly, I'll add this to the safe area view. So I say style equals and some curly braces. And then I just add styles dot container. Now let's add this screen to our app.js file to check everything is rendering correctly. So back in our app.js file, I start by adding the import. And then for now, I'll remove upcoming weather and change this to show the city screen instead. Let's save this and check the simulator. On the simulator, now we can see that our new screen is rendering correctly. So what do we want this screen to do? Well, the city screen will be quite a simple screen. It'll have an image background, which will be city related, and then it will show the name and the country of the city. It will show the population of the city, and also the time that the sun rises and the sun sets. Let's start by finding the image which we'll use for the screen's background image. And then search for city. Just like with the upcoming weather screen, you can use any image you want here, but I'm going to use this one here. So I'll select the image, and then select to download the image. Once the image is downloaded, I'll move it into my assets directory. For simplicity, I'll also rename this to City Background. Now let's go back to our city component. We're going to start by adding ImageBackground to our React Native imports. Then inside the Save Area view, let's remove the text. We'll then need to add ImageBackground. We know for the image background, we need to add the source prop. So let's do that now. We say source equals, and then some curly braces. Inside of the curly braces, we say require, and then add the path to our image. We also know that we're probably going to want to add some styles for this, so let's do that now too. We say style equals, and then we'll call this image layout. So we say styles dot image layout. Inside of our style sheet, let's also add image layout here. And we'll give this flex of 1. Whilst we're here, let's also update the margin top of the status bar for Android, just like we did in the upcoming weather component. So we say margin top, and then we give this the value of status bar dot current height, or 0. And then we need to add status bar to our React Native imports. When we discussed this component, I said we'll need the city name and country, and then we'll also add the population and then the sunrise and sunset times. So let's start by adding 2 pieces of text for the city name and country. We'll hard code in these values for now. So for the name, I'll say London, and for the country, I'll say UK. Let's also add some styles for these. For the city name, we'll call the attribute city name. And for the country, we'll call the attribute country name. Let's add these to our style sheet. So for the city name, I'm going to say justify content of center, align south of center, font size of 40, font weight of bold, and color of white. Next, for the country name, I'll say justify content of center, align self of center, font size of 30, color of white, and font weight of bold. Before we go any further, let's just stop for a moment and take a look at the styles for the city name and country name. Apart from the font size, all these styles are the same. We like to try and keep our code as clean and tidy as possible, and when we start to see duplication, it's a sign that it's possible that we could be doing something a bit better. In React Native, we're able to pass in multiple styles to the style prop by using array notation. So if you're working on the web, you might use multiple class names, but in React Native, we pass the array of the styles to the style prop, and these will get merged into one object. If you have any duplication in these styles, it will be the last definition that is used. This approach is very useful if we have a theme, and then we want to use that theme in multiple places. But then we also have some additional unique styles to apply too. So in the style sheet, I'm going to create a new attribute called city text. And I'm going to move everything inside of this. I'll then remove font size, as this is the value that will be unique for each bit of text. Next, inside country name and city name, I'll remove everything except the font size. Now, back in the render, inside of the style prop, for both of these pieces of text, we need to add an array. Inside of the array, we'll add city text, but then we're also going to make sure that the city name and the country name also remain, as this is where the font sizes come from. So the next thing we want to add to our screen is the population. For this, we're going to show an icon of a person and some text. Because we want to be rendering both of these elements, and also that we want them to show on a row, we're going to wrap these inside of a container. So I'm going to start by adding a view to the React Native imports. And whilst I'm here, I'm also going to import Feather again. So I say import, then I use curly braces, and inside the curly braces, I say Feather from @expo/vector icons. Then I'll go back to the render and I'll start by adding the view. Inside the view, I'll add Feather and also some text. So let's go and look for an icon that we can use with this component on the Expo icons site. I'll search for a user icon, and then I'll select this one here. I can copy the details into the component. I'm going to amend the size to be 50 and change the colour to be red. Now in the text, let's add another hard-coded value. Obviously this is way off for the population size for London, but I'm just going to say 8,000 for now. So to make sure these elements render in a row and to make the text look a bit better, let's add some styles. I'll set a style for the view called population wrapper. And I'll set the style for the text to be population text. Let's add these to the style sheet. So I'll start with population wrapper. I'll say flex direction of row, align items of center, justify content of center, and margin top of 30. For the population text, I'll say font size of 25. Margin left of 7.5. I'll set colour to be red and font weight to be bold. The last details we need to add to this screen are the sunrise and the sunset. Again, these are going to want to be rendered in a row, and I'm going to want to use icons and text for both of these. I'll start by adding a view, and then I'll add feather and also some text. And then I'll repeat this again. So I'll add feather and also some text. So let's start by going back to the Expo icon site and look for a sunrise icon. This one looks perfect, so I'll copy the details and I'll add it to the component. Let's also do the same for sunset. So I'll navigate back to the Expo site and I'll search for sunset. And then I can copy and add the details to the component. For both icons, I'm going to update the size to be 50. And I'll also update the colour to be white. I'm now just going to hard code in some values for the sunrise and the sunset times. For sunrise, I'll say 10:46:58 AM. For the sunset, I'll say 17:28:15 PM. Now let's add some styles here. I'm going to add a rise set wrapper to the view container for these elements. Then I'll add rise set text, both pieces of text. Let's navigate back to our style sheet and we'll add in these attributes. So I'll start with the rise set wrapper. I'll give this a flex direction of row. I'll say align items of center. Justify content, space around, and margin top of 30. Let's also add the rise set text, and this will have a font size of 20, a colour of white, and a font weight of bold. Let's save this and see where things are at in the simulator. So when our app runs, we're now able to see the city screen with the requirements we defined for the screen. We have our image background and the city name and location. We also have an icon for the population and some text for the population. And then we have our sunrise and sunset images and text. I keep going on about how we'll shortly look at navigation to wire up our screens, and I promise we'll get there shortly. I have a few last bits of refactoring I want to do to the current state of our application before we move on. So firstly, if we navigate back to our city screen and take a look at our component, There are 3 places in the render part of this component where we use a feather icon and then a piece of text. This is a great example of when we could extract out something to be a component. We don't have any need to be writing this out 3 times. Instead, we can have a component that renders this and accepts props for the image type and the text which we need to show. So let's go ahead and do this now. We'll start by creating a file in our components directory called icon text. Once this is created, we can navigate to the component and set up our boilerplate. So we say import React from React. We know we need to show some text in this component, and we also want to wrap this in a view. So next, let's import view and text from React Native. We also know this component is going to need some styles, so we can add style sheet to the imports as well. Lastly, let's add feather from @expo / vector icons. Now we can define our component. So we say const icon text equals, then we have a set of parentheses, an arrow, and some curly braces. Outside of this, we need to export the component. So we say export default icon text. Let's also set up our styles before we export the component. So we say const styles equals style sheet dot create. We then use some parentheses and some curly braces. Inside of the component, let's say return, and we'll add some parentheses. Next, we'll add the view. So let's go back to our city component. We can copy the first instance of where the feather icon and the text is used together. So where feather and text are used inside of the population wrapper, I'll copy the icon and also the text. Next, I'll go back to the icon text component and paste this in here. So what props are going to need to be defined for this component? I know I'm going to need to define the icon name and the colour and also the text. So we can set these props up now. I'll change the name inside the feather element to use curly braces. And then I'll pass in icon name. I'll do the same with the colour. And then I'll pass in icon colour. Then in the text, also inside curly braces, I'll say body text. Now, inside the component's parameters, let's add props. Then at the top of the file, we can anticipate these and use some destructuring. So we'll say const, then some curly braces, equals, props. Inside of the curly braces, I'll add icon name, icon colour, and body text. Now let's go back to our city component again. If we take a look at the styles used for population text and rise set text, we can see these styles differ a bit. Both use a font weight of bold, but everything else is different. So how are we going to go about handling this? We can actually just pass these in as a prop as well. So let's start with the commonality and handle the bold font weight first. So back in the icon text component, in the text, we'll say style equals styles dot text theme. Then inside the style sheet, we can add the text theme attribute. We'll say font weight of bold. Now, if we go back to our city component, we can remove the font weight of bold from the population text and then also the rise set text. The remaining styles for these pieces of text will pass down to the child in a prop called body text styles. So let's add this prop to the icon text component. In the destructuring of the component, I'll add body text styles. Now in the text, I'll change the style here to accept an array, as we're going to be passing in multiple styles here. Inside the array, I'll then add body text styles. Great. So now we should all be set up to use this component inside of the city component. So let's start by updating the population text section. So inside of the view, I'll add the icon text component. Next, I'll set icon name, and I'll set this to user. Then I'll add icon color and set this to red. I'll set body text to be 8000 and then body text styles to be styles dot population text. So now I can delete the feather and text elements here. We need to repeat these steps for the sunrise and the sunset. So I start by adding the icon text component at the top of the sunrise. I set icon name to sunrise, icon color to white, and body text to 10, 46, 58 AM. Then I'll set the body text styles to be styles dot rise set text. So now I can remove the feather and text elements for the sunrise. Let's do this again for the sunset. So I add the icon text component again. I set the icon name to sunset, icon color to white, and body text to 17, 28, 15 PM. Then I'll set body text styles to be styles dot rise set text. Now I can remove the feather and text elements for the sunset again. Let's save this and see where things are at in the simulator. So when the simulator runs the app, we see our city screen with the same components as before. This time though, we have a shared component for the icon and text, so we have less duplication in our code. It's really good to pay attention to detail when you're working with your code. The layout for the text does not look centered under the icon, so we should fix that. Let's go back to our code. Next, let's go back to the icon text component. We'll add a style attribute to the view, so we can make sure the items contained within the view are aligned correctly. So I'll say style equals styles dot container. Then I'll add this to the style sheet. Inside of the styles, I'll say align items of center. Now, if I go back to the city screen, I'm going to create some shared styles for the population wrapper and the rise set wrapper. In the style sheet, I'll call this row layout. Inside of this, I'll add flex direction of row and align items of center. I'll then remove these from the population wrapper and also the rise set wrapper. Next, I'll add arrays to both of the style props in the view elements. And then I can add in the row layout for these. In the imports of the component, let's remove the reference to feather, as this is now no longer needed. Then let's do some destructuring for the styles. So before the return in the component, I'll say const, then I'll use some curly braces, and then I'll say equals styles. Inside of the curly braces, I'll add container, city name, city text, country name, population wrapper, population text, rise set wrapper, and rise set text. And then I'll go ahead and remove all the styles and dots inside the render where these are used. So now, if we go back to the icon text component, I'll also do the same thing here. So before the return, I'll say const, then I'll use some curly braces, and then I'll say equals styles. Inside the curly braces, I'll add container and text theme. And then I'll also remove the styles and the dots where these were used inside of the render. So now let's save this and view this again in the simulator. Everything now looks good. So the only screen we haven't yet looked at in terms of refactoring is the current weather screen. If we take a look at this component now, we can see there's a couple of instances where there's a view which wraps two pieces of text. I'm also going to extract these to be their own component. And I'm going to call this component row text. So inside of the components directory, let's start by creating the row text component. Once this is created, we can navigate to the component and set up our imports. So I start by saying import React from React. This component is going to need to use view and text. So I'll say import view text from React Native. We're also going to need to add some styles, so I'll add the style sheet inside of the imports. Now we can go ahead and define the component. So I say const row text, then I use an equal sign, some parentheses, an arrow, and some curly braces. Outside of the curly braces, I'll say export default row text. Before the export, I'll also set up the styles. So I say const styles equals style sheet dot create. I'll use a set of parentheses and some curly braces. Now inside of the component's curly braces, I'll say return, and I'll use a set of parentheses. Let's go back to the current weather and select the first instance of what we want to use in this component. So I'll select the view with the high-low wrapper, and then also the text contained inside of it. I'll go back to the row text component and I'll paste this in. So I know I'm going to need 2 props for each bit of text. So inside the first text, I'll remove the text that says hi, and then I'll use curly braces, and I'll add a prop called message1. Inside the second bit of text, I'll do the same thing again, but this time I'll call this message2. I'm going to want to pass in props for the styles for the view, and also for both pieces of text in the view. So I'll say styles equals, and then I'll add container styles. In the first text, I'll say style equals message1 styles. And in the second bit of text, I'll say style equals message2 styles. Let's update the component parameters to include props. And then we can also add our destructuring to anticipate these props. So at the top of the component, I say const, then I use some curly braces, and then I say equals styles. Inside of the curly braces, I'll add message1, message2, container styles, message1 styles, and message2 styles. Now let's go back to the current weather component and update this to use our row text component. So I'll start by adding row text just before the view with the high-low wrapper. Next, I'll set up our props. So I'll say message1, and I'll set this to hi, 8. Next, I'll say message 2. And I'll set this equal to low, colon, 6. I'll set container styles to styles dot high low wrapper. And then I'll set message 1 styles to styles dot high low. And message 2 styles to styles dot high low. Now I can go ahead and delete the existing view and text here. Next, above the view with the body wrapper, I can follow these steps again. So I add the row text, and then I set up my props. So I say message 1 and set this to it's sunny. Next, I set message 2 and I set this to it's perfect t-shirt weather. I then set container styles and set this to be styles dot body wrapper. And then I set message 1 styles to styles dot description and message 2 styles to styles dot message. Now I can go ahead and delete the existing view and text here too. We need to make sure the row text component has been imported at the top of the file. VS Code has done this automatically for me when I started using the component. Next, let's go back to our app.js file, and in the render, let's update this to show the current weather component. Now let's run the app in the simulator and see how everything looks. When the app runs in the simulator, it looks like something's broken. Debugging errors is a really important process to get to grips with when you're working with your code. Sometimes it's just figuring out how to approach a problem, as opposed to panicking. So how do we know what the problem is here? Well, we know the only components we have changed are the city and row text components. It's the row text component which is not showing on our screen, so let's take a look at that first. The render looks okay, but when we destructured our props, I set this to styles, not props. So this looks like it will be the cause of our problems here. I'll change this from styles to props. Also, we aren't setting anything in our style sheet, so let's clean this up too. I'll remove the style declaration, and I'll also remove style sheet from the imports, as it turned out we didn't need this after all. Let's save this and view the app in the simulator. Everything now looks good. Let's wrap up our refactoring by just doing one last bit of cleanup in the current weather component. For consistency, I'm going to add destructuring to the styles used here. So I'll say const, then I'll use some curly braces, and then I'll say equals styles. Inside the curly braces, I'll say wrapper, container, temp, fields, high-low wrapper, high-low, body wrapper, description, and message. Then I'll go ahead and remove the styles and dots inside of the render function. Let's save this and run the app in the simulator again. Now everything looks good and we have fixed the issue with the row layout not displaying. So now we're ready to go ahead and look at wiring up our app with navigation. When you're building web apps, you can use anchor tags to link between the different pages. If a user clicks on a link or a button to navigate to a new page, then that URL gets pushed onto a stack, which is essentially a data structure, and in this case it would be called the browser history stack. Later, when the user wants to navigate back, then the URL gets popped off the stack, and they're able to go back to the prior page where they'd come from. When you use a mobile app, it's quite unusual these days that it will only have one screen, as they usually have more information to show a user. However, we can't use navigation in the way that we do on the web, so we need some way to navigate between the different screens in our application. In our app, we have already built 3 different screens. We have a screen to show the current weather, a screen to show the upcoming weather, and a screen to show the city details. In order to navigate between the screens, we need to use a navigator. You might have noticed this before, but the other consideration with navigation is how the navigation between the screens occurs. So by this, I mean the transition. When you click something in an app to load another screen, does the next screen then slide in from the right to the left? Or does it perhaps drop down from the top to the bottom? As well as all of this, there's then the different types of navigation to consider, because perhaps we want to use tabs in the app to let the user navigate around. In React Native, there's no built-in navigation, so you have to use a library to add navigation to your app. The 2 most popular libraries are React Navigation and React Native Navigation. While both of these libraries have the same end goal, the implementation of the 2 differs. The other consideration between the 2 libraries is that React Navigation is built into Expo. So if you created your app with Expo, you can use it just fine. However, if you want to use React Native Navigation, you would have to eject your app from Expo, or you would have had to create your app without using Expo, and I showed you how to do this at the start of the course. So in our app, we're going to be using React Navigation, and our goal is to implement tabs for the user to navigate between our different screens. So let's start by installing React Navigation. To do this, in the terminal, we need to type npm install at react navigation /native. Next, because we're using Expo, we have some additional dependencies we need to install to get everything up and running. If you're not using Expo, you can see the additional installation steps required to get up and running with React Navigation here. So for Expo, we need to run npx expo install react native screens. React native safe dash area dash context. So once everything is installed, we need to set up a navigation container. This will wrap the entire application, and usually we'd only do this once in the application, and we do it at the root of our project. So we're going to add this to the app.js file. So we start at the top of the file and we say import. Next, we use curly braces. And we need to make sure we use a capital N. And we say navigation container. And this is imported from @react -navigation /native. Next, inside the render, at the top, we need to place a navigation container. Then we close this at the very bottom of the render so that it contains everything. At the start of this section, I discussed how, on the web, we push and pop items off of a stack. With React Navigation, we follow a similar idea, except that we do this via a navigator. So the screens can get pushed and popped off of the navigator. There are two types of navigators we can use, and this depends on our requirements. Essentially, if we don't want the user to navigate to a screen using a tab, then probably we'll want to use the stack navigator. So let's look at some examples to show this a bit more clearly. If I load this example on Snack from the React Navigation website, I see a settings screen. If I click the button that says Go to Profile, I'm then navigated to the profile screen. Next, if I then click the back icon, the profile screen is popped off of the navigation stack, and I'm back on the settings screen. For this kind of navigation, you would want to use a stack navigator. At the bottom of the screen, there are also some tabs. When I select one of these, the screen the user sees changes, and this is the behaviour I want for our application. If you want to explore more deeply all the kinds of navigation available to use with React Navigation, then you can visit this GitHub repository. And then you can navigate to the example section. If you load this, then you can play about with everything. So for our app, as I said, we want to use tabs to let the user navigate between the different screens. It's up to you when you create your app to decide where you want the tabs to show, as you can show them on the bottom of the screen or the top of the screen. There are some platform considerations to bear in mind here too, as often on Android you have tabs at the top of the screen, and on iOS you have them at the bottom. In our app, we're going to display the tabs at the bottom of the screen. But if you wanted to show this on the top for Android and the bottom for iOS, you would need to set up Material Top Tabs, and then decide which to display based on the platform. You can access the platform the user is using by using the Platform API from React Native, and then you can use the OS property. So back to our tabs. We need to start by installing the bottom tabs. So we say npm install @React Navigation /bottom tabs. Once this is done, if we go back to our app.js file, we can import this. So underneath the import for the navigation container, we say import, then we use curly braces, and inside the curly braces, we say create bottom tab navigator. And then we say from @React Navigation / bottom tabs. Next, before the component is defined, we need to say const. Then using a capital T, we say tab equals, and then we say create bottom tab navigator, and follow this with parentheses. By doing this, we're initializing the tab object so that we can use it. Next, we want to wrap all our components inside of the tab navigator. So inside the navigation container, we say tab dot navigator. And then we close this just before the closing navigation container. So next, we're ready to go ahead and add our screens. So I say tab dot screen. And then I set the component name. So I say name equals, and as a string, I add the component name. And so the first one for us will be current. And next I add the component. So I say component equals, and then I'll set this to current weather. Then I repeat this again for the other two screens. So I say tab dot screen. And then I set the component name, which is upcoming. And I set the component to upcoming weather. Lastly, I say tab dot screen, and this time I set the name to be city. And I also set the component to be city. So now we should have just set up the 3 screens for our app. Let's save this and see what things are looking like in the simulator. When the simulator runs the app, we see a screen with an error. The error says a screen can only contain screen, group, or React fragment as its direct children. So clearly we made an error here. The only file we've changed directly is the app.js file. So let's go back to that file and take a look. So when we set up our tabs, we did not remove the view container. This is neither a screen, group, or React fragment. So let's remove that. I'll remove the view. Then in order to keep things tidy, I'll remove the view from the React Native imports. I can also remove the styles that were used for this. There are no other styles set now, so let's also remove the style sheet declaration, and then also the import for style sheet. Let's save this and run the app in the simulator again. This time the app loads, and I can see the 3 tabs set up. When I click through the tabs, I'm able to navigate to the different screens on our app. It doesn't look very pretty though, so we'll go ahead and start looking at how to make this look a bit better. So there's lots of configuration options available to us with React Navigation. As we can see here in the documentation, we can set a tab bar icon. If we look a bit more deeply into the documentation, you can see there's a wealth of other things available too. So we can set labels and positions and so on. In our app, we already have the names showing on the tabs for the different screens, but we're going to customize things a bit further. we're going to set an active and an inactive colour for the tab bar. Then we're also going to set icons for each of the tab bar items. As we can see in the documentation, we set the active and inactive tint colours on the navigator, and then we set the icons in the tab. So back in our code, in the tab navigator, we're going to say Screen Options. Then we'll use an equal sign and some curly braces. Inside the curly braces, we use another set of curly braces. And then we say tab bar active, tint colour. We're going to set this to the string tomato. Next, we'll say tab bar inactive tint colour. And we'll set this to be grey. For the tab icons, we're going to use some icons again from Feather and Expo icons. So we'll start by importing this at the top of our file. We say import, then we use some curly braces, and inside the curly braces, we say Feather. Then we say from @expo / vector icons. So to set the tab bar icon, we can use the tab bar icon property. As it says in the documentation, we can use it on our screen components in the options prop, although for their example, they've placed it in the screen options prop of the tab navigator. In our implementation, we'll be using it in the screen components options. So in the first screen, I say options. Then I use an equal sign, and then I use two curly braces. Next, I say tab bar icon. And for the parameter, I'm going to pass in focused. This is because we're going to want to set a different colour for the icon depending on whether the tab bar icon is or is not selected. Next, I use an arrow and then some parentheses. Inside the parentheses, I'll render the feather icon. So I just say feather. I've already selected the icons for the tabs here, so I'll say name equals, and inside curly braces, I'll set this to be droplet. I'll set size to 25, and inside colour, if the icon is focused, we want to return tomato. Otherwise, we want to return black. Now we need to repeat these steps again for our other two screens. So in the screen with the upcoming weather, I say options, then an equal sign, and two curly braces. Next, I say tab bar icon. And for the parameter, I pass in focused. Then I use an arrow and some parentheses. Next, I set up the feather icon. This time for name, I'll set it to be clock. I'll set size to 25, and for the colour, I'll say if focused, then show tomato. Otherwise, show black. Then for the city screen, we do this again. So I say options, and I use the 2 curly braces. Inside of the curly braces, I then set the feather icon up. I set name to home, size to 25, and for the colour, I say if it's focused, use tomato. Otherwise, use black. So now the tab icons and styling should be set up. Let's save everything and see where things are at in the simulator. So back in the simulator, we see all of our tabs set up with the tabs and the icons. Everything should now be running correctly. In order to make our code a bit easier to follow, I'm going to extract the tabs into their own component, and then I'll import this into the app.js file. So inside the components directory, we'll create a file called tabs.js. Next, back in the app.js component, I'm going to copy all the imports and the initialization of the tabs. Then I'll paste this into the tabs file. Now I can go ahead and create the component. So I say const tabs equals, then a set of parentheses, an arrow, and some curly braces. Inside the curly braces, I'll say return, and I'll use some parentheses. Outside of the component, I'll say export default tabs. Now I'll go back to the app.js file and I'll copy everything related to the tabs. Next, I'll paste this into the tabs.js file. Back in the app.js file, we can now delete all the code related to the tabs. Now, if I go back to the tabs component, I need to update all the imports for my screens, as we're now inside of a directory and not at the root of the project. Back in the app.js file, I can then delete all the imports which are now not needed. Lastly, in the render, I can just pass in the tabs component. So now everything's much more readable. Let's save this and view it in the simulator. Everything looks good, and we see the tabs in the simulator still. When I click on a tab, it changes colour, and our tab code is extracted into its own component, so everything is nice and tidy. If we go back to the code for the tabs component, you may see an ESLint warning. I'm going to just disable this warning for this file, as we need to follow the React navigation requirements and set up our tabs in this way. So before we move on, let's add a few more customization details to our navigation. In the header bar, I get the same name as I do for the tab name, so we don't need to change this, but I'm going to set the background colour of the tab bar and also the background colour of the header bar. After that, I'll go ahead and add some more styles to the font used in the header bar. So in my screen options for the tab navigator, I'll say tab bar style, and then I'll use an object. Inside of this, I'll say background color, and I'll set this to light blue. This is all one word and all lowercase. Next, I'll set another property called header style, and I'll also use an object here. I'll set the background color also to light blue. Then I'll set a property called header title style, and I'll also use an object for this. Inside of this object, I'll say font weight of bold, font size of 25, and color to be tomato. Let's save this and check things out in the simulator. So now we can see our tab bar and header bar both have a matching background color. The font in the header bar is a bit larger and bolder, and the color of the selected tab matches the color of the header bar title. There's a ton of customization options available to you with React Navigation, so I strongly advise you spend some time getting familiar with the documentation. You can see a bit more about the header bars here. So we're shortly going to move on and look at state and then data fetching in our app. After that, we'll look at using the real data in our components. In order to prepare ourselves for this, though, there's one more file I would like to implement. In our current weather component, we currently have an icon and a message description set for when the weather is sunny. In the completed app, we're going to show a different icon and a different message based on the weather. Additionally, we're going to change the background colour of the screen to represent the different weather. We'll base these different states on the weather conditions provided by the Open Weather Map API. So we're going to create a file which contains these conditions, and then the icons, message, and background colour, which should be shown for these conditions. So we'll start by creating a directory to store this, which will be called utilities. So let's do that now. In the src directory, we'll create a new directory called utilities. Then we'll call the file, which will store these properties and values, weather type. Inside the file, we need to create an object. So we say export const weather type. And then we set that equal to an object. Because of the data provided by the API, we need to capitalize the weather types. We'll start by creating the objects for each of the weather types. The first one is called thunderstorm. The next is drizzle. Then we set rain. Next we'll set snow. Then clear. Clouds. Haze. And mist. So let's start by setting up the thunderstorm type. We'll set an icon and give this the value of the string zap. Next we'll set a message and we'll set this to the string it could get noisy. And then we'll set a background color to the black hex color value of 000,000. Note that this is passed in as a string. So the next one is drizzle. This one will have an icon of cloud dash rain. Then for the message, we'll say it might rain a little. Then we set the background color to 36454F. For rain, we'll set the icon to umbrella. And then for the message, we'll say you will need an umbrella. And the background color will be 000,0FF. For snow, we'll set the icon to cloud dash snow. For the message, we'll say let's build a snowman. And the background color will be set to 7F6065. Next, for clear, we'll set the icon to sun, and we'll set the message to it is perfect t-shirt weather. And the background color will be set to E47200. Now for clouds, we'll set the icon to cloud. We'll set the message to you could live in the clouds. And then the background color will be set to 363636. Now for haze, we'll set the icon to wind, and the message will say it might be a bit damp. And then for the background color, we'll set this to 58586E. And then lastly for mist, we'll set the icon to align dash justify. The message will be set to it might be hard to see. And then the background color will be set to 3E3E37. Right, that was a lot of typing, but now we can try this out, even though we don't have any real data yet being used. If we go back to the current weather component, we can start by importing this file. As we're not importing a component, but we're importing an exported object, we need to use curly braces. So we say import, and then we use curly braces. Inside the curly braces, we say weather type. And then we import this from utilities / weather type. So let's test this out on the weather condition message. So inside the last row text component, inside the message to prop, we can just say weather type and then use square brackets. And let's try out the message for the thunder weather condition. So as we're using square bracket notation here, we pass in the string. Let's save this and see what things look like in the simulator. So now we're going to move on to some of the more deeper topics in React Native. And we're going to take a step back from our app, just for a bit, in order to take the time to learn some of the details required to successfully make our app more dynamic. Dynamic is the key word here. So far in our application, everything has been static. This means that we have all our screens, and all of these are now wired up with navigation. But nothing in our app really does anything except display values to the user, which we have hard-coded in ourselves. If this is all you wanted to do, then you only need to use props, just like we have, and you can pass your data around from parent to child components. But isn't the real excitement of making applications these days how interactive we can make them, and how fun we can make the experience for the user? When was the last time you enjoyed using an application, either on the web or on mobile, that only functioned in this way? With React Native and React, we're able to make the user experience super interactive and update and respond to users' input. So given this intention, props are only half of the story. The other half is state. State is what I'm going to introduce you to now. So what is state? To put it simply, state is an object, and this object contains data about the component that for some reason we decide we need to keep track of within our application. In the object, we define key value pairs, and these key value pairs are the way in which we track a single piece of data that over time is going to change. Let's visualize this a bit more. If we go back to the house example from when we looked at props, using the props, we pass data down to each of the rooms in the house. Using state, though, we can be inside a room and keep track of something that is going to change in the room. So perhaps we want to keep track of the messy state. Or maybe we want to keep track of whether the room was dark, so we could track the value dark as true or false. Or maybe we know a massive storm is incoming, so we want to keep track of whether or not the room is wet. The benefit of state within a React Native or React application is that it means things can change. They can be added, modified, and removed. And we, as the developer, can work with this more easily and update our internal data and trigger UI updates based on these changes. There is one very key point to be aware of here, though. When the data in our component changes, the component will re-render. So to emphasize this point, when a component first renders on the screen to the user, we have what is called an initial render. If we're using state, and some of this state changes, then the component will re-render itself. So let's look at this through our room example when the storm is possibly incoming. Our room component renders on the screen when it first loads. We have a wet state, and this is set to false. Later, the storm happens. Our room gets flooded. This causes the wet state to get set to true. Consequently, the room component then re-renders. In the world of coding, this sort of change might be more likely to occur based on a user event, such as a button press, or perhaps some sort of user input, such as typing something into an input field. It's totally fine if this all seems a bit overwhelming or confusing right now. It can be a lot of information to process. Let's stop for a moment and summarise what we have just learned. We have learnt that state is an object that is used to keep track of data about a component. We've learnt that by using state, we can add, remove, or modify things in our component more easily, and then we can trigger UI updates based on these changes. Additionally, we've also learnt that when state changes, it causes the component to re-render. So let's just be very clear now on the difference between props and state. Props let us pass data between the components, whereas state lets us internally manage the data within a component. You therefore can't modify the state of the component outside of the component. In this sense, it's a bit like when you're working with local scope in JavaScript. Of course, with vanilla JavaScript, you can make things dynamic, but the benefit of working with React Native and React is that a lot of the hard work is done for you, and you just have to provide initial values and then consider how you would like this value to update, and then also be displayed to the user. If and when your state grows, you need this to be at an application level, then you can also access libraries to help you manage this, such as Redux. But that is out of the scope of this course. So we're going to continue our journey with state by creating a simple counter component, which won't be in our final app, but will hopefully solidify our understanding a bit more here. We'll start by creating the component without using state, so hopefully we can better see why we need state, and then we'll add state to the component. So inside the src directory, I'm going to create a new directory called demonstration. You're welcome to keep the code in this directory for reference purposes, or delete it from the final project at the end of the course. But it saves us from having to create a new app for any demonstration code which we'll make during the rest of the course. So in the src folder, let's create this new folder called demonstration. Now, inside of this folder, I'm going to create a component called counter.js. We'll set this up just like we have with our other components. So we'll start by importing React from React. Next, we'll import View, Text, Button, and Style Sheet. And we'll import these from React Native. Now let's go ahead and create the component. Hopefully you're getting used to doing this now, but we'll start by saying const counter, and we'll follow this by an equal sign, some parentheses, an arrow, and some curly braces. Outside of the curly braces, we'll export the component. So we say export default counter. Inside of the curly braces, we'll say return. And we'll use a set of parentheses. Then before the export, we'll create our style sheet. So we say const styles equals style sheet dot create. And then we use some parentheses and some curly braces. So let's set up our component. Before the return, I'm going to create a variable which will store the value of count. So I say let count, and I set this equal to 0. Now inside of the return, we can create a view. Then we'll also create some text. Inside of the text, we're going to use a template literal and interpolate in the count value. So we use curly braces and then some backticks. We say count and a colon. Then we pass in the count variable. Next, we'll add 2 buttons. For the first button, we'll set colour to red. For the title, we'll say increase the count. And then we set on press. For this, we use an arrow function. So we use some parentheses and an arrow. For the first one, I'm actually going to use curly braces because there's a little bit more I want to do here. So firstly, I'll increment the count. So I say count plus plus. And then I also want to add a console log to print out the value of the count variable. For the second button, we'll set the colour to green. For the title, we'll say decrease the count. And for on press, I'll just pass in an arrow function, which will decrement the count. Let's add a couple of styles. On the view, we'll set a container. So I say style equals styles dot container. And for the text, I'll set some styles called title. So I say styles equals styles dot title. In the style sheet, I'll set the container. I'll give this flex of 1 and background colour of orange. Next, I'll set the title. I'll give this align self of centre and font size of 25. And then I'm going to set a margin top of 25. We also need to be able to see this component on the screen of our app. So let's go back to our app.js file. I'm going to start by importing the counter. And I'll do this from /src/demonstration/counter. Temporarily, I'm going to remove the tabs from the render in the component and replace this with the counter. Now let's load the simulator. We now see our counter component on the screen. We see the 2 buttons and also the text which displays the counter value. Great. So let's now click the button to increment the counter. So it looks like the button was pressed successfully, but the count value has not updated on the screen. Let's dig into this a bit more and we'll check the console log we added. So it looks like this did increment. I'll press the increase button again. We now see 2. So the counter value is definitely increasing, but the text that displays the count on the screen is not showing the correct count. So the reason for this is that React does not re-render a component when the value of a variable changes. If this happened, we would end up with re-renders happening all over the place, and it would result in a really bad user experience. I mentioned when we looked at state that when we use state and the state changes, the component re-renders. So this is a great example of a use case for state. We'll look more deeply at hooks in a bit, but we're going to use a hook provided by React called useState in order to fix our problems here. For now, you can think of a hook as functions that we can use inside of our function components. All of the components we have made throughout this course have been function components. So to start off, we need to import the useState hook. We do this when we import React. So in the React import, we add a comma and then some curly braces. Inside of the curly braces, we say useState. Now, when any values we use with the useState hook are updated, then React will ensure the component also gets updated to reflect these changes to the user. So now we need to update the declaration for our count variable and use the useState hook instead. So let's delete the variable and we'll start again. This time we use the hook. So we say const, and then we use square brackets. And we say equals useState. Inside the square brackets, I'll say count, and then set count. Lastly, inside the parentheses for the useState, I'll set the value 0. So when we use the useState hook, we're setting up some piece of state for our component. When useState is set up, we need to pass in the initial value for what the state should be. So if we were implementing the flooded room example here, we might have to set this up by saying is flooded and set is flooded. And then in the parentheses, we would have said false for the initial value. We want the counter to start at 0, which is why here we're passing in 0. We can pass in any of the data types required for our needs though, so this could also be a string or an object and so on. The square brackets where we have added count and set count are simply using array destructuring. The first value in this is the count, and this tracks the value for the count. But we never directly change the value of count. Instead, we use setCount, which is a function, and into this we pass what we want the new value for count to be. So let's go ahead and update our component to use this. In the first button, I'm going to remove the console log, and also the incrementing of the old count variable. Then I will say setCount, and I will pass in count plus 1. So we aren't modifying count here, we're just getting the value of count and then adding 1 to it. In the second button, I'll say setCount, and this time I'll pass in the value of count again, and then -1. Let's save this and go back to the simulator. Now let's press the increase button. The count displayed on the screen updates to show our new count. Now let's press the button to decrement the value. The value on the screen now decrements. So now we have successfully worked with state for the first time. Let's recap what we have just learned. When we want to use useState in a function component, we can use a hook called useState. We never directly change the value for the state, but we can update it via a function that enables us to update the state. We use array destructuring for the useState hook, and inside this we have the value for the state, and then the function we use to update the state. And inside this we have the value for the state, and then also a function that we can use to update the state. Inside the parentheses of useState, we also set the initial or default value for the state. Before we move on, in the last section I introduced you to hooks, and I want to go over these in a bit more detail, and then I'm going to move on to showing you another hook which will help us with our data fetching. Back in the older days of using React and React Native, in the most part, we had 2 types of components that we could use. These were called stateful and stateless. If we wanted our component to use state in some way, we would create a stateful component. If we did not need to use state in our component, then we could use a stateless component. A stateful component was a class, and the syntax for a class component looks like this. We can still create class components in React today, so they're worth knowing about, and you may very well come across some older code that uses them. When you use class components, you can access what are called lifecycle methods. Lifecycle methods are essentially events that occur during the lifecycle of a component. It's a little bit like key events that occur during the life of a human. A human gets born, they have an annual birthday, and later in their life they pass away. When a component is created, it is mounted, and the lifecycle method for this event is called component_did_mount. When the component updates, another lifecycle method is called, which is named shouldComponentUpdate, and this lets you control when the component should re-render. Just before the component is destroyed, another lifecycle method is invoked, called component_will_unmount. When you're using a class, you can tap into these methods, and during these events, you can add some additional functionality. If you want to read more about lifecycle methods, you can find some details here. As React has evolved, there's been a tendency to move away from using class components, and these days function components are favoured. When components were either stateful or stateless, this wasn't very practical. But in React 16.8, hooks were introduced. Hooks provide us with a way to use the features we depended on classes for, like state and lifecycle methods, but from inside of our function components. You can think of hooks like special functions, or pieces of reusable logic which are separate from our component tree, but that let us add functionality to our function components. When we use hooks, we can isolate all the logic from the component in a readable way, but we can use them within our component. You can read more about hooks here. Every hook in React starts with the word use, and we've just seen an example of this when we looked at the useState hook. There are a couple of rules you should be aware of when you're using hooks though. Firstly, you can only call hooks from React functions, like our functional components. You can't just use them wherever inside normal JavaScript functions. Additionally, hooks must be called at the top level of a component, and before the return keyword is used. We'll see more about this later, but aside from React hooks, you can also create your own hooks, and these hooks can call other hooks. We're going to move on now to introducing ourselves to another hook from React, called useEffect. After this, we'll return back to our app and start looking at data fetching. The useEffect hook is extremely powerful, but it can also seem quite overwhelming when you're first looking at it. If you can understand how to use the useEffect hook properly, then you can do all sorts of things with your application. Let's start by looking at the documentation. So it says the effect hook lets you perform side effects in function components. The example also goes on to state that it's similar to component_did_mount and component_did_update. Let's break this down a bit. To start with, what is a side effect? Well, it's when we use something not inside of React within our component. So examples of these sorts of things are fetching data, using timer functions, and updating the DOM directly. We also know that component_did_mount happens when the component is first mounted, and component_did_update is called after updating occurs. So useEffect essentially lets us replicate these lifecycle methods, and it means we can perform side effects, like fetching data, from within our function components. So let's go ahead and look at the basic syntax for the useEffect hook. If we look carefully, we can see that useEffect takes in a function as an argument, and it's inside of this that we can write our side effects. Let's add the useEffect hook to our counter example so we can understand things a bit more deeply. So inside the counter component, next to the useState import, we need to start by also importing useEffect. Next, under the useState hook, we can use useEffect. So we say useEffect, and then we pass in a function. Now inside the function, let's add a console log for the count. So I say console log, and then inside this I'm going to use backticks. And then I'll say our count value is, and then I will interpolate in the value of count. Now let's see this in action in our simulator. I'll start by reloading the screen. So now, in the console log, I see the initial value of count printed to the screen. Every time I click one of the buttons, as the component is re-rendering here, I see the new value of count printed to the screen too. So we could be doing anything in here that we want to happen as soon as the component first renders, such as fetching some data. Right now, we're also repeating the code inside of here every time that the component re-renders. If we take a look at the React docs again, we can see that useEffect also takes one other parameter called dependencies, which it compares to the lifecycle method component did update. It says on the documentation that you can tell it to skip applying an effect if certain values have not changed between renders. To do so, you pass an array as an optional second argument to useEffect. So to summarize this a bit, inside of this array, we pass in all of the values that the side effect inside of useEffect relies on. In our example, we're console logging based on the value of the count. So we need to include count inside of the dependencies array. This now means that the code inside of useEffect will only run if that value has changed between renders. If we do not pass in the dependencies array, then the code inside of useEffect will run after every render. Let's look at this in our demonstration. I'm actually going to add 2 new buttons to the component. I'll just copy and then paste the first 2 buttons. Next, I'll create another count and set count with a new useState hook. I'll call the state variable here new count. And then for the function to update the state, I'll call it set new count. And then I'll update the onPress inside of the new buttons to call set new count. So now, inside of the useEffect, I'm going to change the console log to just be count changed. Let's run this in the simulator. When the screen loads, I get count changed printed to the console. Every time I press any of the buttons, I see the count changed console log printed to the screen again. So now let's go back to our code, and we're going to pass in a dependency array. Inside of the dependency array, I'm going to pass in count. Now let's run this again in the simulator. So I get the console log printed to the console when the screen launches. This time though, I only see this printed to the screen again when I click on any of the first 2 buttons, which use count. I don't, however, see it printed to the screen when I press any of the buttons that use new count. So the effect only runs when count changes, otherwise it just sits there and it doesn't do anything again. The last thing you need to be aware of when you are using useEffect relates to the component will unmount lifecycle method, and it's called the cleanup function. This cleanup function allows us to turn off or clean up our side effects. So for example, if you're using a counter, we would need to use the clear interval function to stop the counter, and this is where we would place that, and by doing so, we can avoid memory leaks. To use a cleanup function, we type return, and then we use an arrow function, followed by the cleanup we would like to perform. We can see an example of this on the React documentation again. As the documentation says, React performs the cleanup when the component unmounts. So we don't really have any cleanup we need to do in our example, but I'm going to add a console log here to show how this works. So back inside of our code, and inside of the useEffect, I will say return, and then I'll use some parentheses, an arrow, and some curly braces. Then I'll just console log a string which says useEffect cleanup. Let's save this and go back to the simulator. Now when I click one of the buttons, which triggers a re-render, I also get the console log for the cleanup logged to the screen, because the cleanup is called before the next useEffect runs. So before we move back to our app, let's do a bit of recapping about everything we've just learned with useEffect. We have learned that useEffect is a hook provided by React, which lets us run code that has side effects. We've seen that it takes a function with the code to run. Then we saw that you can also pass in a dependency array, which lets you specify what data, when changed, that you would like to trigger a re-render. Lastly, we looked at the cleanup function that we can use with useEffect to run any cleanup and stop any of the side effects before useEffect is called upon a new render and when the component is unmounted. So now we have some understanding around hooks and useState and useEffect. So we're ready to go back to our app and think about our next steps with our weather application. So, back in our app, we have a few things that we're going to do now in order to make the app dynamic. To start off, inside the app.js file, I'm going to reset the code to use the tabs inside the render. And I'm also going to delete the import for the counter. I'm going to break down the next steps we need to achieve. The first thing we're going to do is implement a loading state for when the app first launches and the data is being fetched. This is so the user sees something during this process. It's always good when you're making applications to consider all the various loading and error states that the user might encounter. After this, we're going to look at fetching the data from the OpenWeatherMap API, and this will be broken down into two parts: getting the user's location and then fetching the data. So let's start first with the loading state. As I mentioned, we want to start the app in the loading state until the data from the OpenWeatherMap API is successfully fetched. Once it is fetched, we'll set the loading state to false and navigate the user onto our weather-related components. For our loading state, we want to display to the user a spinner. Instead of having to manually create this, React Native has a core component that does this for us. It's called Activity Indicator. Let's have a look at the documentation. So we can see the Activity Indicator displays a circular loading indicator to the user, and we can customize the size and the color of the spinner. On the documentation, we can see a few of the activity indicators in action, with the different sizes and colors set. So let's go back to our app, and we'll start to set this up. So inside the app.js file, we'll start by importing the activity indicator. After the React import, I'll say import, then I'll use some curly braces, and inside the curly braces, I'll say activity indicator. And I'll import this from React Native. Next, in order to set the loading state, we're going to use useState. So in the React import, I add a comma, some curly braces, and then inside the curly braces, I say useState. Now this is imported, we need to set up useState. So before the return, inside of the app component, I say const. I use some square brackets, and then I say useState with some parentheses. I'm going to call this piece of state loading. So inside the square brackets, I'll add loading. I'm going to call the function to update the state setLoading. So I'll add this too. Then I'm going to set the initial state for our loading state as true. This means when the app first launches, the user will see the activity indicator. Then once the data is fetched, we can set this to false, and then they'll see the weather components. So now in the render, we need to have a way to say, if the state is loading, then show the activity indicator. Otherwise, show the tabs. There are a few ways we can implement conditional rendering in React and React Native. Knowing about if-else statements, ternary operators, and also the logical AND operator is useful when it comes to handling these scenarios, and you can read more about these here. In our case, for now, we're going to keep this very straightforward and just use an if statement, which renders the activity indicator when the loading state is true. If the loading state is not true, then the navigation container and the tabs will be rendered. So inside of our app component, I'm going to say if loading. Then inside the parentheses here, I'll say return. And inside the return, I'm going to add a view. And then also the activity indicator. So we're wrapping the activity indicator inside of a view here so we can better control the layout for it. For our activity indicator, we're going to say size equals, and then we'll set this to the string large. And we're also going to set the color, so we say color equals, and then we set this to the string blue. We also want to set a couple of styles for the view, just so we're sure we're setting the layout for the activity indicator to be in the center of the screen. So in the view, I say style equals styles dot container. Now in the React Native imports, we need to add the view and the style sheet. Before the component is exported, let's set up the style sheet. So I say const styles equals style sheet dot create. And then I pass in the object. I'm going to set the container. And for this, I'm going to say justify content of center and flex of 1. Let's save this and see how it looks in the simulator. When the simulator runs, I see the loading spinner in the center of the screen. If the loading state was set to false, I would see the tabs and our weather screens. So next, we're finally ready to look at getting data from the API. So in order to get data from the OpenWeatherMap API, we need to start by calling the API. Let's take a look back at the API documentation on the OpenWeatherMap website. For our app, we want to display the current weather, but also the upcoming weather. So we're going to use the 5-day, 3-hour forecast. If I click on the API documentation here, it shows us how to make the API call. As we can see, there are a few things that are required to make this successfully. We will need the latitude and the longitude, which are geographical coordinates for where we want to display the data from. And then we're also going to need our API key. Let's start by figuring out how we will get the latitude and the longitude. The technical term for finding geographic data, such as coordinates, is geolocation. If I search for React Native geolocation, we can see that this has been deprecated, and we should use one of the community packages instead. If I click on the link, we can see that there are a variety of packages available. So this is useful if you did not create the app with Expo, and it's also something to know about in the future. But as we created the app with Expo, we're able to use a package called Expo Location. Let's take a look at the documentation for this. So as it says, Expo Location allows reading geolocation information from the device. This sounds exactly what we're looking for. Let's start by installing it. So in our terminal, we need to say npx expo install expo location. Now, if we go back to the documentation, we can see all the extra configuration. And then there's also steps provided if you're installing the project in a bare React Native project. In the example provided, we see that we have to complete 2 steps in order to get the user's location. Firstly, we have to ask for permission to access their location. And then we need to get their location. Once we have their location, we need to store this. We also need to be mindful of handling any errors in case we were not able to access the user's location. So for implementing this successfully, we're going to need to use useState in order to store the location and any errors. And then we're also going to need useEffect. So back in our code, let's start by importing useEffect. Next, we will set up 2 pieces of state. We'll do the location first. So we say const, then we use square brackets, and we say equals useState. Inside the square brackets, we'll say location. And then set location. We're going to initialize this with null. Now for the error, we need to set up another piece of state. So we say const, then we use square brackets, and we set this equal to useState. This time in the square brackets, we'll say error and set error, and then we'll initialize this with null. Next, let's set up the useEffect. So before the return, we say useEffect, and then into this we need to pass a function. We're going to pass in a function which needs to be immediately invoked. So inside of the curly braces, we use a set of parentheses. Next, we say async. This is so that JavaScript knows we're using an asynchronous function here. Then we can set this up as a function. So we use parentheses, an arrow, and some curly braces. Inside the curly braces, we say let, then use curly braces, and we set this equal to await, location, dot, request, foreground, permissions, async. Make sure you capitalize the location here. We want to access the status, so inside the curly brackets, we're going to place status. Next, we handle the error using an if statement. So we say if status does not strictly equal granted, then we use our setErrorState function. And we set this to the string permission to access location was denied. And then we say return. Now, outside of the if statement, we can continue with the rest of the code for if the request for permissions was successful. So we create a variable using let called location. We assign to this await, location, dot, get current position, async. Into this we pass in an empty object. Lastly, all we need to do is update the location. So we say set location. And into this we pass in the location. Then, as we want to immediately invoke this at the end of the function, we use a set of parentheses. Inside of the useEffect, we'll pass in an empty array for the dependencies. This means there's no dependencies, and that useEffect will only run once when the component is first rendered. In our component, we're just going to add a console log for now, and we'll say if location, then console log location. Before we test this, we need to ensure location is enabled on the simulator or emulator. You can see more information about how to do this in the documentation here. Let's go ahead and test this out in the simulator. When the simulator runs, we see the permission request which we set up. When I click on Allow while using the app, and then launch the console, I then get to see the location data, which includes the latitude and longitude, which we were looking for. It's worth knowing here, as a side note, that when you're using a simulator, the location defaults to San Francisco as opposed to your real location. So now we have this, let's look at getting data from the API. At this point, it would be helpful if you're signed in on the OpenWeatherMap API website. To start with, I'm going to navigate back to the 5-day, 3-hour forecast, and then I'll open the documentation here. Next, I'm going to copy and paste the URL for the API call that we're going to need, as we're going to need that shortly. For now, I'll just paste this at the top of the app.js file. So we need to think about how in the app we're going to store the API key. It's always best practice and safer not to expose any secrets in your application and import them from an external place. This is even more important if you're using source control like GitHub, because you don't want these keys to be visible to anyone. There are a few ways you can go about doing this, and there's some deeper documentation on the Expo site here if you would like to find out more about this. For our example, we're going to use a package called reactnative.env. This means we can use an environmental variable where the value is set from outside of the application. So let's go ahead and set this up. So we need to start by installing it. Back in our terminal, we'll say npm install -d react native.env. Once this is installed, we need to go to our Babel config file and then add the plugin. So after presets, we need to add a comma. And then for the key, we say plugins. And then we use an array. Inside of this, as a string, we say module, React, native, .env. So now we can create the .env file. So at the root of the project, I'm going to create a file called .env. Once this is done, we can test this out. I'm just going to use a dummy value for now, using capitals, which is the best convention. So first I'll set the name of the key to be test _ key. Then I'll say equals, and for this I'll just say 1, 2, 3. Now if I go back to the app.js file, I can import this. So in my imports, I say import, then I use curly braces, and I say from @env. Inside the curly braces, I place the name of my key, which was test _ key. So now I'll just add a console log with this. Let's save this and run the app in the simulator. When the simulator runs, if I check the console, I can see the value of the key printed successfully. So we've proven the package was successfully set up. Let's go back to our app. As I'm using Git, I want to make sure the .env file is not pushed. So inside the git ignore, I will add the file name. This means it will not be part of any committing and pushing to Git that I do. So next, let's go back to the .env file. We'll delete the test key, and we'll add our key for the Open Weather Map API. I'll call this key weather _ API _ key. The next thing we're going to need to do is to get the API key. So back on the Open Weather Map website, as long as you're signed in, you can click on your user and then My API Keys. On this screen, you can copy and paste the key if you have one. Otherwise, you can generate one by selecting Generate and then copy and paste it. If you now go back to your .env file, you can paste it in. And then we should be good to go. So the last bit of setup we need to do here, if we go back to the app.js file, we can change the import for the test key to be Weather API key. Now we can look at how we're going to fetch the data. So to fetch the data, we're going to use the Fetch API, which is what React Native provides us with to work with networking. If you haven't used this before, you can read more about it here, and also here. So back in our app.js file, we're going to start by creating a new piece of state to store the weather data. Hopefully you're becoming more familiar with this now, but we'll say const. Then we'll use a set of square brackets, and we'll set this equal to useState. We'll call this weather. So let's add that into the square brackets. Then we'll call the function to update the state, setWeather. We'll initialize this as an empty array. So next, we're going to encapsulate this data fetching inside of a new function, which we'll call fetchWeatherData. So before the useEffect, we'll say const fetchWeatherData. And we'll use an equal sign. And then async. Next, we'll use some parentheses, an arrow, and some curly braces. So now inside the curly braces, we can then set the response. So to start, we declare a variable using const called res. And to this, we'll say await, fetch, and some parentheses. Inside the parentheses, we can paste in the URL we want to fetch the data from. So we're going to use backticks here, as we're going to need to interpolate in our environment variable. So we'll say http : and 2 forward slashes. Next, we can paste in the URL that we commented out earlier. We'll update these values shortly. So next, we need to create another variable to get the JSON data. So we'll say const data, and we'll assign to this await response dot JSON. Once we have this, we can call our setWeatherState function. So we say setWeather, and into this we pass data. Also, once this is done, we can set the loading state to be false. So we say setLoading and pass in false. Then inside of the useEffect, after the location is set, we can say await fetch weather data. So let's now format the URL that we passed into fetch. So inside curly braces, we have the latitude and longitude and also the API key. So to start with, we need to get the latitude from our location piece of state. So we say location dot coords dot latitude. And then we can do the same for the longitude. So we say location dot coords dot longitude. Now where the API key is, we can pass in our weather API key. We also need to make sure we're using interpolation here, so we need to add dollar symbols before each of the curly braces. There's also some error handling we need to do here, so if the response fails in some way, we can set our error state. To achieve this, I'm going to wrap everything inside of a try-catch statement. So I say try, then I use some curly braces, and then I say catch. And I place error inside of the parentheses. Then I use another set of curly braces. So inside the try, I will place everything we've written. And then inside of the catch, I'll say set error. And then inside parentheses, I'll use a string. And for this, I'll say could not fetch weather. Additionally, I'm going to use finally here. This is used to execute something after the try catch has been completed. So I'll say finally, and I'll use another set of curly braces here. I'm going to move set loading from the try statement into here. The reason I'm doing this is so that we have either the data or the error. Once either of these is set, we can set loading to false, and then we can navigate to the correct screen for this state. Of course, this also means we're going to need to add a screen to show the user if there is an error, but we'll add that a bit later. So there's one last bit of refactoring I want to do now. When we initially set up the location, we set one piece of location and then pulled out the required values in the API call. I'm going to update this so we have two separate pieces of state, one for the latitude and one for the longitude. So I'll start by creating these. I say const, and then I use some square brackets, and then I say equals, useState. Inside this, I'll place an array. I'll call the state lat, and then the function to update the state, setLat. Next, I'll do the same for longitude. So I say const, then I use square brackets. I initialize this with an empty array. I'll call the state lon, and the function to update the state, setLon. Next, inside the useEffect, instead of saying setLocation, I'll say setLat, and then location dot coords dot latitude. Then I'll do this again for the longitude. So I'll say setLon, and then I'll pass in location dot coords dot longitude. Then I can update the API call instead to use the lat and lon pieces of state. Additionally, I'm going to pass these in as dependencies inside of the useEffect array. This means when these change, the useEffect will rerun. Let's also remove our initial location piece of state. So now let's add a console log to see if we can view the weather data. So we'll say if weather console log weather. Let's save this and see how things are in the simulator. So now when we look in the console, we can see the weather data has now been set up and is visible to us. So now we have all the data we need coming down from the API. Next, I'm going to do a bit of refactoring because our app component has quite a lot of logic inside of it at this point. So I'm going to extract the current hook usage into an external file. You can make custom hooks and then import them, just like when you use a React hook. The benefit of this is that we can better encapsulate the logic. In our case, we're going to end up with quite a few things going on, so doing this means our code is much easier to work with. The only requirement when we do this is that we name it with something that starts with use, just like when we use hooks which are from React. So to start, I'm going to create a new directory called hooks. Now inside here, I'm going to create a file called useGetWeather.js. I'll go to this file and I'll start by creating the function. So I'll say export const useGetWeather. As this is a function, I need to use an equal sign, some parentheses, an arrow, and some curly braces. Let's think about what we need to add in here. We want all the data fetching logic from the app.js file, so let's start by getting that, and then we'll paste it inside of the function. We're also going to need to get all of our state, because this is depended upon by the functionality inside of the hook. So back in the app.js file, I'll copy all the state setup. Then I'll go back to the custom hook file, and I'll paste this at the top of the useGetWeather function. Lastly, we're also going to need some of the imports. So let's grab everything from the app.js file, and then we'll paste it at the top of the hook file. So we can delete the React Native and the navigation imports here because they're not used. Lastly, at the end of the hook, we need to return, inside of an array, the pieces of state that will be needed by our app component. So for us, this is the loading state, the error state, and the weather data. The app component itself does not need the latitude and longitude, so we can keep these scoped only inside of this hook. So at the end of the hook, after the useEffect, we say return. And then we use an array, and we'll pass in loading, error, and weather. At this point, we could actually now use this hook inside any component we wanted. So this is really helpful if you have some reusable code which is required by multiple components, as it means you don't need to duplicate logic. Now we're ready to use the hook in our app component. So if we navigate back to the file, we can start by importing the hook. I'm also going to delete all the unused code now. So now we can use this, and we simply just destructure the values. So at the top of the app file, we say const, then we use square brackets, and we set this equal to useGetWeather. The values to place inside of the array are loading, error, and weather. So now we can add a console log with loading, error, and weather. Let's save this and test this out in the simulator. When the simulator runs, I now get to see the loading, error, and weather data printed out in the console. So we have proven this works, and we now have all our logic scoped inside of its own hook. So the next thing we're going to do now is look at wiring up each of our weather components with the real data. So to start with, we need to pass the weather data to the tabs, and then we'll need to decide which pieces of data are required by which component. So back in our app.js file, let's set a prop on the tabs called weather. And we'll set this to weather. I'm also going to change the render order here. So if the weather exists, we render the tabs. otherwise we'll show the activity indicator. So I'll place the rendering for the tabs to be above the rendering for the activity indicator. And then I'm going to enclose this inside of an if statement that says if weather and weather.list, then return the navigation container. Then I'll remove the condition around the activity indicator and just return this. So essentially here we're saying if the weather exists with the data, we'll render the weather, otherwise show the activity indicator. We'll update this a bit more later to show an error screen if the error state is true. So now let's go back to the tabs component. Now inside the tabs component, we can start using this. If we take a look at the data that we get back from the API, we can have a think about what each component will need. The current weather component only needs the current weather, so we can pass it the first element of the list array. For the upcoming weather, we can pass everything from the list array. Then for the city, we can just pass in the city data. So we're going to do this process component by component, and we'll start with the current weather component. In order to pass the props to the component, we need to render a callback to return the element to use for the screen, instead of using the component prop. So let's start by setting this up. We'll remove the component prop, and then we'll set up the tab screen to return a child. Now we can pass in the component, so we use curly braces, a set of parentheses, an arrow, and then the current weather component. On the component, we'll pass the props. So we say weather data, and we set this to weather dot list. And then using square brackets, we'll access the element at the position of 0. So next we can go to the current weather component, and we'll add the weather data prop. Let's add a console log for this and check everything is wired up correctly here. So I'll run the app in the simulator. Now I'll check the console. Brilliant. I now see the data in the console, and we're good to go with wiring up this component to use this data now. So let's open our current weather component. Now we can have a think about what we need to do in order to get this up and running properly. The pieces of data I'm going to need for this component are the temp, feels like, temp max, temp min, and weather. So to start with, I'm going to destructure these from the props. So I start by saying const, and then I use a set of curly braces. Everything except the weather itself I need to get from main. So I say main, I say temp, feels like, temp max, and temp min. Outside of the curly braces, I use a comma, and I say weather. Then I set this equal to weather data. Next, in order to access the correct weather type object, I'm going to need access to the weather condition. So I'm going to create a variable to store this. I'll say const weather condition, and I'll set this equal to weather square brackets 0 dot main. The first thing we're going to do is update the background color for the screen so that it's set dynamically from the weather type utility file. Because we want to use a property based on the data, we're going to need to do this inline so that we have access to everything we need. So for the style on the safe area view, we'll add in an array. After the wrapper, we'll add a comma. Then we'll use inline styles to set the background colour. So we use an object, and inside this we'll set background colour. We'll set this to be weather type, and then we need to pass in the weather condition. So we'll use square brackets, and then inside of the square brackets we'll place weather condition. Outside of the square brackets, we then want to access the value of the background colour. So we say dot background colour. Next, we can do a similar thing to dynamically set the icon. So for the feather element name, we'll add curly braces. And then we'll say weather type. And then we'll use square brackets. Inside the square brackets, we'll say weather condition. And then outside of the square brackets, as we want to access the icon, we'll say dot icon. I'm also going to update the colour to be white. Next, we can update the temperature text to use the temp value. So we need to add curly braces here as we're passing in a value. And then inside the curly braces, we can add temp. For the feels like temp, we also need to use curly braces. Here I'm going to use a template literal, so inside the curly braces, I'll add backticks. Then I'll say feels like, and I'll interpolate in the feels like value. The first row text shows the high and low temperature, so I need to update the message 1 and message 2 values. I'm going to use template literals here again. So for the message 1, I'll use backticks. Then I'll say high, then a colon, and I'll interpolate in temp max. For message 2, I'll again use backticks, and I'll say low, colon, and I'll interpolate in temp min. For the next row text, we want to show the weather description, which comes from the data, and then we also want to show the weather type message. So for message 1, I'll say weather, and as this is an array, I need to use square brackets and pass in 0. Then I say dot description. For the message 2, instead of passing in thunderstorm, I can remove this string and instead just pass in the weather condition. Let's save this and see how things look in the simulator. When the simulator runs, I see the current weather component, but we're now using the values from the weather type, and everything is using the real data. There is one thing though, the units are currently in Kelvin. On the Open Weather Map documentation, we can see this is the default. On our app, we want to use metric, so we need to add this to the API call. If we go back to the useGetWeather hook, we can append this to the API call. We use the AND symbol, and then we say units equals metric. Now, if we reload the simulator, we can see the new values. This screen will now look different every time the weather type changes. So that is our current weather component updated for now with the data. Next, we can move on to updating the upcoming weather component. Let's go back to our tabs and set this up. So back in the tabs component, we'll remove the component prop and then set up the tab screen to return a child. Then we can pass in the component. So we use curly braces, and then a set of parentheses, an arrow, and then the upcoming weather component. Next, on the component, I'll say weather data, and I'll pass in weather.list. This means we have access to all the upcoming data. So next, I'll go back to the upcoming weather component, and I'll pass in weather data to the component. I'm going to start by removing all the dummy data we added. Additionally, I'm going to remove the title for the component. So I can also now remove the text from the imports. Next, in the data prop of the flat list, I'll pass in weather data. The values for the list item inside of render item are already set up from the dummy data. So now we can go straight to the list component and see what we need to update. In this component, we also have all the props set up from the dummy data, but we need to do some refinements here. I'm going to start by updating the icon to use the icon from the weather type dynamically. So to start, I need to import the file. So I say import, then I use curly braces, and inside the curly braces, I add weather type. And I'll import this from utilities / weather type. Then for the feather icon name, I'll remove the string sun. And I'll say weather type, square brackets. I'll pass in condition into the square brackets. And then I'll say dot icon. Because space is limited for the list item, I'm then going to change the min and max temperature to be all on one line. And I'm also going to round these values. So to start, I'll delete the text with max. Then I'll use a template literal and interpolate in math dot round. And I'll pass in min. Then I'll interpolate in math dot round, and I'll pass in max. I'll separate these with a slash. Also, we want to show the degree symbol on each of these values. On a Mac, I can do this with Option Shift 8. On a Windows, this is Alt 0176. Next, we'll look at formatting the date text, and I'm going to use a library to help us with this called moment.js. Moment.js helps us pass and format any data related to time and dates. It's a really useful library to know about because it provides a lot of options for how to display what can sometimes be quite complicated data to the user. Let's start by installing it. In the terminal, I need to type npm install moment -- save. We're going to split the date text into two sections, one that shows the day and one that shows the time. So back in the component, let's add another piece of text under the one that currently shows DT text. Also, to display these, we're going to want these to be split onto two lines. So we'll wrap these inside of a view. And then we'll set some styles here. We'll just call these date text wrapper. Inside the style sheet, let's add this. And then we can set flex direction to column. Now to format the value, we need to start by importing moment. So at the top of the file, we say import moment from moment. So let's have a quick look at the documentation. On the first line, we want to show the day, so we can do this by passing in dd. We then want to show the time on the next line, and we can do this by passing in h s. Let's go back to our component and set this up. So for the piece of text where we want to show the name inside of the curly braces, we say moment and then pass in dt.txt. Then we say .format and we pass in the string dd. In the second piece of text, we say moment and again pass in dt.txt. Then we say .format and this time we pass in h, ss, and then followed by a space, followed by a. So the a will show the AM or PM. Let's save all of this and see how this component now looks in the simulator. When the simulator runs, we now see all of our list data showing on the screen with the new layout improvements. So next we need to go back to our tabs component and move on to wiring up our city screen. So back in the tabs component, we'll remove the component prop, and then we'll set up the tab screen to return a child. Next we can pass in the component. So we use curly braces, a set of parentheses, an arrow, and then the component. Now we can pass in the data. So we say weather data, and we pass in weather.city. Now let's go back to our component. Let's start by setting the prop in the parameters. And then we can destructure out the values we're going to need. So I say const. Then I use some curly braces. And I set this equal to weather data. Inside the curly braces, I'll add name, country, population, sunrise, and sunset. The first value we're going to update is the city name. So I can remove London, and I'll add some curly braces. Inside the curly braces, I'll add name. I can now do the same for country. So I remove UK, and then I add some curly braces. Inside the curly braces, I'll add country. Next, I can update the first icon text, body text value. I'm going to use a template literal here, so I'll remove 8000. Then I'll use some backticks. Then I'll say population, colon, and I'll interpolate in population. I can then move on to updating the second icon text. I'm going to use moment again here to help us with our formatting. So I'll import moment from moment at the top of the file. Now back in the body text, I will say moment, and I'll pass in sunrise. Then I'll say dot, format, and pass in h, colon, colon, ss, and then a space, and a. Then for the last icon text, body text value, I'm also going to use moment again. So this time I say moment, and I'll pass in sunset. Then I use a dot, and I say format. Inside format, I pass in h, colon, colon, ss, then a space, and a. Let's save this and see how it looks in the simulator. Everything for the screen looks good, and this has now also been updated to use the data from the API. So that's all our existing screens set up to use the data. There's just a couple of minor fixes I want to do. I want to add the degrees symbol to the current weather component. So let's go back to that component now. In the first two pieces of text, I'll add the degree symbol here. I also want to add a space between the high and low text. So on the message 1 prop here, I'm just going to add a space at the end. So now we have these refinements done, let's move on to creating an error screen for the application. Inside the components directory, I'm going to create a component called error item. Now inside this component, we can set it up just like a standard component. So I'll import React from React. Then I'll import view, text, and style sheet from React Native. I'm also going to import feather from @Expo icons. So now we can declare the component. I say const error item equals, then I use a set of parentheses, an arrow, and some curly braces. I'll make sure the component is exported, so at the bottom of the file I say export default error item. Before the export, I also need to set up the style sheet. So I say const styles equals style sheet dot create, and I'll pass in an object here. Inside the component, I'll say return, and then I'll add a view and some text. Inside the text, I'll pass in the message, sorry, something went wrong. Next, I'm going to add a feather icon. So I'll say feather, and then I'll set name to frown, size to 100, and color to white. So let's set up the styles. On the view, I'll say style equals styles dot container. On the text, I'll say style equals styles dot error message. Then inside the style sheet, I'll set container, and I'll say flex of 1, background color of red, justify content of center, and align items of center. And then for the text, I'll say font size of 30, color of white, margin horizontal of 10, and text align of center. Now let's test this out. In the app.js file, we can start by importing error item from components error item. Next, in the render with the activity indicator, we can use a conditional and say if loading, then return the activity indicator. Otherwise, return the error item. To test this, I'm going to go to the useGetWeather hook. At the bottom of the hook, where we return the values, I'll say true for the error, and I'll add an empty array for the weather. This just means we now have the state set up in order to test out our error item. So let's save this and see how it looks in the simulator. When the simulator runs, I see the error screen that the user would see if something went wrong when the location and weather are being set. Let's go back to our hook file and revert the changes we just made so we set the error and weather back in the values returned by the hook. So now let's go through our app screen by screen and check if there's any other refactoring we need to do. When I look at the current weather screen, I can see we need to add the degree symbol to the initial temperature value. I also want to slightly decrease the font size in the description and message. So let's do that now. Back in the component, I'll add the degree symbol to the temperature. Then in the style sheet, I'm going to remove the pink background colour, as this is now not needed. Then I'm going to set the description font size to be 43, and the message font size to be 25. I'm lastly going to add optional chaining in the places that we are accessing nested object properties. This means undefined will be returned if one of the properties does not exist instead of an error. Next, let's take a look at the upcoming weather screen. As we're using white text, I think the background colour of the list items is slightly light, so let's update that. Let's go back to the list item component. I'm going to set item background colour to be Indian red. This is all one word and all lowercase. Lastly, I'll add optional chaining where we're using the weather type. Everything looks a bit better in the simulator now. So let's take a look at the city screen. Everything on this screen now looks good to go. So we're ready to move on to making the final touches to our application. The last thing I want to do on our app is adjust the app component very slightly. I want to change the conditional to show the error item if the error state is true, and then otherwise show the loading screen. This just ensures that the user really does only see the error screen when there is an error. So I'll say if error, then show error item. Otherwise, show the activity indicator. So that is everything done, and our app is now complete. Before I wrap up this course, there's a couple of last topics I'd like to introduce you to, but you can consider this as bonus material. The first one of these topics is the Context API. You may have noticed when I implemented the tab screens as children that the documentation said that it advised you use the Context API. The reason I did not do this is because we only have 3 core screens on the app. However, if you're in a position where you're passing the data around a lot of components who are very far away in the component tree, and also perhaps if the state is complex, then the Context API is very handy to know about. It's also really useful if you have some global data which is needed throughout the application, such as a user's name or some theming for the application. By using the Context API, all the logic can become centralized. It's not specifically the right or wrong approach, it very much depends on your use case, and it becomes a slightly different way of handling your data instead of props. So you can share anything through the context, and once we share the data, the component can ask the context for the bits of data it needs. It's important not to overuse context, and definitely don't think of it as a replacement to props. But it's an approach that it's worth knowing about for when you need to access specific pieces of global data throughout the application. The documentation about context is here, but essentially there are 3 steps to creating context. You need to start by importing the context. Then you would define your context. So if you had a room context, you'd say const room context, and you'd set this equal to create context. Then you wrap the context around your components, and at this point your components can access the context. The last couple of topics I wanted to cover are UI-based topics. We haven't had the need in our application to create a button, although we have seen how the React Native button component works. Did you notice how this didn't really look like a button that you might have expected? Another common task when you're developing applications that you may encounter is creating custom buttons. React Native has a set of touchable components which help us with this. If we take a look at touchable opacity, we can see that it's a wrapper for responding to touches. Alternatively, we have touchable without feedback, but this doesn't give us a visual response, so this is likely not what you want to use when you're creating a button. In the demonstration directory that I created earlier, I'm going to go ahead and implement a button, just so that you're familiar with how to achieve this. And then I'll start by setting up the component. So I'll import React from React. Then I'll import View, touchable opacity, and text from React Native. Next, I'll set up the component. So I say const rButton equals, and then a set of parentheses, an arrow, and some curly braces. I'll then export the component. So I just say export default rButton. Next, I'll set up the style sheet. So I say const styles equals style sheet dot create. Into this, I pass in an object. So next, in the component, I say return. And then I'm going to use touchable opacity. And inside this, some text. For the text, I'll just say hello. Then on the touchable opacity, we pass in onPress. And we'll set some styles. So we say style equals styles dot container. We'll also set some styles for the text. So I say style equals styles dot button text. In the style sheet, I'll add these styles. So I'll start with the container. I set elevation to 8. This sets the elevation of the item on Android only. Next, I say background colour of blue. Border radius 10. And I'll set padding to 5. Then for the button text, I'll set font size to 15. Colour to white. And align self to centre. Then on the touchable opacity, we set an onPress prop. So let's set this up. We use this to define what we want to happen when the user presses the button. So I'll set up an arrow function called onPress. And inside this, I'll add a console log, which just prints out press. To test this out, let's go to the app component. I'll comment out the navigation container render. And then I'm going to import the button. So I say import rButton from demonstration rButton. Then I'll add this to the render before the activity indicator. Let's test this out in the simulator. When the simulator runs, I get to see the button. If I open the console, I can see the press is printed out every time that I press the button. I strongly advise you spend some time playing about with all the core components in React Native, as there's a lot you can achieve. You can look at modals for alerts, text input for text input fields, and the switch component acts like a toggle.